And 5, 4, 3, 2... Yes. How are you, sir?
Good.
Welcome.
Thanks for having me up.
Thanks for being here, man. I wanted to ask you this because I was reading this today and I'm starting to freak out. NASA is planning on drilling into Yellowstone
Okay.
to save the world.
I don't know about this.
You know about
They're
this?
relieving pressure? What are they doing?
Yes. Yeah. There's been thousands.
Chiropractic?
Yeah. We were talking about chiropractors before this started, folks. I think they plan on like, you know how like if you have like a giant cyst and you sort of make a slice in it, you can kind of squeeze everything out of there. You ever see a doctor do that?
I've seen doctors do that. I've never seen NASA do this. I have no idea what
NASA
this is
wants to
talking
send. NASA wants to spend $3 billion drilling into a volcano to save the United States. And presumably a large chunk of the world, too, right? Because there would be some sort of a nuclear winter type scenario where the skies would be covered with... This is not your area of expertise.
It's not my
I'm sorry
area.
to throw this on you.
I wonder about the provenance of this. But, you know, these are things that it's some people's areas of expertise, but no one has figured everything out, right? Like, we don't know all the forces that are pushing around the Earth to make volcanoes and earthquakes, stuff like that. So,
Go back to that picture. Look at this picture.
Yeah.
That picture freaks me out.
That looks realistic. Yeah.
Every 600,000 to 800,000 years, that thing blows sky high.
Microsoft Paint version of geophysics. Yes.
Yeah, it's from like a GeoCities site from 1994.
Yeah. Well, here's the thing they have to think about, right?
Can you keep this up close to you? Pull
Sure.
It. Yeah,
Yeah.
just pull it.
There's all sorts of disasters that could happen to us that we
Right.
don't really plan for because human lifetime is 100 years, technology is a few hundred years, but maybe there are disasters that happen every 1,000 or 10,000 years, right? And they could be very bad. I think solar flares are the ones to really worry about, to be honest.
Is that what you're concerned with?
It's not my professional concern, but I was once sitting next to a hotshot lawyer who had just been finished visiting Washington, D.C. to campaign for we got to start hardening up the electrical grid because one kind of solar flare that he says happens every 1,000 years could wipe out electricity in the United States or the world for weeks or months. Millions of people would die, right? So a few $1 billion and we can harden it and fix things, but who's going to spend a few $1 billion for something that happens once every 1,000 years?
Isn't that the issue? It's like even with preventing asteroids or doing something to avoid collisions, it's right now we don't have an issue. So we go, we have other things to worry about. We have a terrible president. We have global warming. We have this, we have that. There's always something that keeps us from being rational about the future.
Yeah, that's right. And with the good news with asteroids is that there's other good reasons to look at the sky and map things, right?
Yes.
So what astronomers are doing are piggybacking asteroid mapping strategies off of things they can actually get money for, right? Because, no one is going to pony up that much money to look at the asteroids.
God, well, I would think that would be like a really good use of money. Like, let's keep an eye on the rocks that might kill everything.
You would think that everyone would save for their retirement and so forth, right? But this ability to plan for the future, not what we evolved for.
Well, that's a big ability. I mean, that's a big plan for the future, though. I mean, literally, you're talking about, like, wasn't there one that just whizzed by that was 3 miles wide?
Yeah, but whizzed by means it was something like 8 times as far away as the moon. I mean,
is that what it was?
Yeah, this is not... There's the chances of an asteroid, even though it'd be very bad, the chances of a bad one are much smaller than some of these other things.
You don't comfort me.
All right. Well, I'm not here for comfort. I'm here for the truth. Take the comfort as you will.
But isn't there, like, there's a lot of areas they can come from, like behind the sun, where the gravity of the sun sort of distorts the view?
Not really.
So how
there's
does
no
that
place
work?
to hide. They got to orbit, right? They can't stay behind the sun. They can. There's what's called a Lagrange point. There's a place exactly the opposite where the Earth is, where you'd have to hang out if you were to be hidden from us for a long time, and you can hang out there, but you would never leave there. So there probably are some asteroids right opposite the Earth, just like most planets have them.
So they're just sort of orbiting, is that what you're saying?
Yeah, they're orbiting once a year, 180 degrees away from the Earth, and that's what they will be doing until they're gradually
Is it possible
moved
that
away.
one can come up and hit us from the bottom when we're not looking?
No, that's not possible.
No way?
No.
How's that not possible?
No, the danger is something from far outside the distant solar system that we just haven't. This too far away, too dim.
And it
right?
wouldn't come from like where the South Pole is.
Very roughly speaking, we're looking at the whole sky, not just you can see below the South Pole if you're in Chile, for example, where there's lots and lots of telescopes.
That's where they have that. What is the giant one that they put in Chile recently that's not totally operational?
There's a whole generation of telescopes. I forget which one it is that's there. Yeah, but one of them, is it the Giant Magellan Telescope maybe? It's in Chile?
Yeah. I don't know what one it is. Yeah. I think they're just still working on it now. Yeah. The Chile is because it's is it because it's a high altitude and the environment is very...
It's high, flat, and dry. Yeah. So Hawaii is another good place to put telescopes, but that's gotten in trouble with local resistance and astronomers just not even trying to take that into consideration and therefore getting themselves in trouble. Canary Islands are okay, but Chile is one of the best places. Chile and Antarctica, actually.
I've been to the Keck Observatory a couple times.
Cool.
I've been 3 times, and every time I go, like the first time I nailed it, and every time I've been since then, I haven't gotten, like one time we went and I didn't plan for the moon. And I was there's too much moon out, and it was just too bright. The sky was too bright. And then the next time, unfortunately, we got it when it was rainy and kind of cloudy, and we didn't get a good vision. But the first time changed my life. I mean, I really felt like I was on a spaceship looking through a window.
Do you know what they were observing?
I don't know. Well, we were actually just at the visitor center.
Okay.
Just looking at the visitor center, the sky is so magnificent at night. Yeah. You know, there's no light pollution. They use diffused lighting on the island, the whole deal. And the image that you got from just looking up, I mean, just with the naked eye, it's just spectacular. It's just an amazing view of the Milky Way.
That's why the telescopes are there, right?
Yeah. And but it gives you a perspective that I think we're missing with our cities, and I think we've done something amazing by creating these cities where, you just walk down the street and get some food delivered. You can go get a car. You can, go buy a TV. There's all this stuff in these congested areas, but in putting all this artificial light, we've removed our connection with the view of the cosmos. It's
absolutely true, and I'm the biggest booster of cities. I love cities. I love living in them. I think that they're good for the planet, etc. But it does exactly like you said. It sort of makes our environment so artificial that we forget. I remember a great story a friend of mine told me. She worked for an organization called Project Exploration, which is based in Chicago. They're devoted to bringing the wonders of science to kids and minorities and so forth. And they do these trips from Chicago on the train out to like Montana to dig up dinosaur bones, right? And so they're out there. They get to go on a ranch. They get to dig up real fossils, bring them back. And she said the thing that got them the most, that was most affecting to them, was they saw stars for the first time in their lives, right? They'd grown up in Chicago. They'd never seen a star in the sky, and I think that's a shame.
Yeah, you see like these faint little flickering things. You don't see like the view of like the Milky Way where you actually look up and you see that white sort of stripe across the sky and you realize, oh my God, that's stars. Those are all stars.
The Milky Way is the best. I get dizzy looking at it, right? Knowing that we're at the edge of this spinning disk whirling around, and if you don't get vertigo, you're not doing it right. Yeah.
As a person who studies space, do you ever take time to like go out into the desert and just stare at the space with nothing out there, no light pollution?
Not that much. Honestly, the thing that I study are equations and formulas and theories. And I use space. My friends who are observers go out there and collect the data and figure out what ideas we have are right and which ones are wrong. And I love it when I get the chance, but I don't go out of my way any more than anybody else does.
You were saying that people were asking about general relativity. Was that the
quantum mechanics?
Quantum mechanics.
Yes.
Oh, okay.
People on Twitter said, all right, I hope to figure out quantum mechanics for the first time here. So they look up to you for this. Yes.
Well, the problem
is... It is not impossible.
Well, I don't think... I'm just joking.
Right.
But what I'm... very touchy. But it's one of those things where everyone is hoping that someone is going to be able to boil it down.
Right.
And simple. And Neil deGrasse Tyson does a very good job of doing that with the cosmos. Yeah. He's been able to boil down quite a few things on this show where a lot of people went, thanks, man. Finally, I kind of get it, sort of.
Yeah. He's fantastic. He has an amazing ability, especially off the cuff. Well, it seems like off the cuff. I have this vision that he goes home every night and plans out answers to every possible question because they're so slick when he delivers them.
He does a little because I've heard him give the exact same off the cuff. But they're great. So it's not like a stand-up comedian delivering a line.
It's new to you.
Yeah,
exactly.
That's right. Yeah. So what is it about it that they don't understand, you think?
Quantum mechanics, I think that's the subject of the next book that I'm writing, a book I'm working on right now. So I'm just starting thinking about it. But it's not just the people on the street. It's my professional colleagues with PhDs in physics who don't understand quantum mechanics. And rather than being embarrassed by that, rather than thinking, wow, this is, a terrible thing that we should devote all of our resources to understanding, they flip it. It's like Aesop's fox and the grapes, the parable where the fox is trying to get the grapes and he realizes he can't reach them. So he says, I never wanted them anyway. They're probably sour, right?
Right.
So that's what physicists are like with quantum mechanics. Like now, if you try to understand it at a deep level, they disrespect you. You're like, why are you wasting your time doing that when we could be calculating some numbers, right?
Ego and knowledge. It's always a weird combination. I've always assumed when I was younger that, well, when you get to the highest levels of science or, any sort of intellectual pursuit, that the people that are really involved, there wouldn't be any ego issues. It would all, you're laughing, See, as an outsider, I was like, well, there's ego in every other part of the world, but those super smart dudes that are figuring everything out, they got all that stuff locked down.
Kind of the opposite of that.
Really?
Yeah, really.
That's so disappointing.
And I love them. These are my people,
Right.
And
but
it's well. I'll explain quantum mechanics eventually.
Okay,
but
please.
But you are right. This ego thing. The one thing about academia, being a professor, right, whether it's science or anything else, is that you are constantly being evaluated by every other person you meet. There's a hierarchy. There's a rank, how good you are at everything, right? And it's not written down necessarily. There's not a rankings that appear in the sports pages, but everyone is judging you all the time. And, my students and so forth, they say, well, I don't like to ask questions in a seminar because I worry that someone's going to be judging me. And all I can say is that, yes, they are going to be judging you.
God, that's so crazy.
And even at the very, 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 very tippy top, it's like, am I number 2 or number 3, right? And it's very sad. And it's not everyone's like that, but most people in the field get to be like that, and probably it helps forward the advance of science, right?
The competitive nature of it all.
Yeah, it's competitive and egotistical, and they want to do better than everybody else and prove that they're better. And I'm sure Einstein and Newton were just as driven by that as anybody else.
Isn't it weird? It seems like human beings need that comparative sort of competition thing going on in order to forward whatever they're doing. They need peers. They need some sort of...
It helps. It's there, yeah. We live in a world with scarce resources, right? Some of us are going to live longer than others. Some of us are going to get tenure, and some of us are not. And some of us are going to be Nobel Prize winners, and some are not. So no matter what, there's going to be competition. Yeah.
Yeah, and in your field, there is a big issue, I guess, with people disregarding other people's discoveries, or wanting to, rather, like wanting to poo-poo things. And
I think this is a very complicated issue that I don't really have clear, because certainly scientists can be very, very supportive of each other under the right circumstances, but they're human beings. There's all sorts of cognitive biases that they have, prejudices, Bayesian priors for what's likely to be true, what's not likely to be true. And it's not just perfect reasoning, perfect rationality, right? People come in with their prejudices, and if you go and tickle their preconceived notions, they'll think you're great. And if you say something that doesn't quite fit into what they're thinking about, then they'll sort of look somewhere else.
Diminish you. Do you teach this when you're teaching classes and you're addressing potential future cosmologists and quantum mechanics? What do you say? Quantum mechanics? No. What mechanicists?
Yeah, there's no good word for a person who does. Quantum physicist is good. Yeah.
Do you tell them about the potential pitfalls, and you maybe plant a seed in their head, like, hey, you can avoid this. You can still be competitive, but avoid all these traps that are essentially like these intellectual rabbit holes you can go down that are really not beneficial to anybody.
Yeah, if I'm formally teaching a class, if I'm standing up there in front of the lecture hall, 98% is teaching the material pretty straightforwardly. I try to dribble in little words of wisdom here and there, and especially if I think that there is a way that we always teach the subject that is wrong and wrong-headed and we should be doing it right, I try to highlight the differences. But if I'm advising students, like my graduate students or my undergraduates, then I lay on very hard my own perspective on how it is to be a scientist, and what is the good way to do it and what's the bad way to do it, what are the pitfalls, and also just how to not make mistakes and trip up your own career. Yeah, that's crucially important.
Now, what is it about quantum mechanics that you think people don't understand?
Well,
is there
everyone
a way
agrees.
to describe it that way?
Yeah, everyone agrees on what we don't understand.
Okay.
There's the thing that makes quantum mechanics, which is our single best theory of the universe in some sense. The thing that makes it difficult to understand is that it's the only theory you've ever invented where there is a difference between what the world is and what we see when we look at the world, right? In every other theory, if we look closely enough, we would see the world as it is. And quantum mechanics has this fundamental rule that says you can't see the world as it is. If you have an electron, right, a particle that can be spinning clockwise or counterclockwise, you think that's what can happen because every time you look at it and you say, is it spinning clockwise or spinning counterclockwise, you get one answer or the other. But the rules of quantum mechanics say when you're not looking at it, it's in a superposition of both. And you can calculate the probability that you're going to get one answer or the other. And this drives people crazy because they think that what they see is what is real. And therefore, they have very, very difficult times figuring out how to make a sensible theory of quantum mechanics that explains what you actually see.
Yeah, even you just explaining that, it's circling around inside my brain. I'm looking for like a cubby to place this, and like, where does this go?
Right.
What superposition? What?
Yeah.
What is he saying? He's saying that it's in two different places at the same time, or that it's still and in motion at the same time?
Good, right. So that's right. So exactly what you're doing right now, you're saying that there are things that it can be still in motion, this place, that place, and somehow it's in both at once or something like that.
Yeah.
And what quantum mechanics says, it's not in either. Like if you ask where is the position of the electron, there's no such thing as the position of the electron. If you look at the electron, you will see it in a position. But that is not the fundamental essence of the electron. There's something called the quantum state or the wave function. There's a mathematical way that we have of representing the reality of it. But the answers it gives us to questions are just not, here it is, there, how fast it's moving, et cetera. That's not what we calculate using the theory.
Does this, is this sort of, I mean, it's very bizarre, right? And it's very complex. And does this sort of lend itself to get hijacked by woo-woo folks?
Oh, totally. Yeah.
Which is why, like, what the bleep? Like, what the bleep do we know? That was when I first started really paying attention to this stuff. Yeah. And then I was reading criticisms of what the bleep, and that's when I got an understanding, like, oh, okay, well, this is kind of horseshit, and this lady is kind of a channeler?
Yeah.
Like, what? And they're in a kind of a cult sort of a deal?
Yeah.
Like, what?
Yeah.
Wait a minute. What? Like, when she was saying her name was Ramtha, I was like, that's her real name?
10,000-year-old warriors are being reincarnated.
I didn't know that. How come they didn't put that in the movie? Like, there's a lady in the movie, if you've seen what, like, and so many people are like, oh my God, that changed my life. The movie changed my life. Because all of a sudden, they thought that, like, magic was real. And it is. Kind of, right? I mean, it's not magic, but...
It's not magic. The world is not magic.
But when you look at an atom and realize that most of it is space, like most of the things that we're looking at are mostly space, and that subatomic particles really do kind of blink in and out of existence, and you look at all the various quantum weirdness that is real and observable by people like you that actually study this stuff, it looks crazy.
Yeah, in fact, so I hate to be that guy, but both the claim that atoms are mostly space and the claim that particles popping out of existence are both entirely bullshit.
Oh, please educate. Tell me more. Why do people say that all the time then?
Because they're privileging what you see when you look. Right?
Privileging, like white privilege or different kind?
Exactly like that. You know, they have a view of what should be. Right?
Okay.
And so if you have an electron in an atom, we have a mathematical way of describing it. And it's a cloud. It's not located anywhere. It's not empty space and here's the electron and most of it, the rest of it is empty. It's not like a little miniature version of the solar system, right? The solar system is mostly empty. There's empty space in between the planets. And if you draw a picture of the atom or look at one from your high school science book, an atom looks just like the solar system, right? A nucleus at the center and these things moving around it. That's not what it is. Oh. It's a smooth cloud that is everywhere inside the atom. And that cloud is the answer to the question, were I to look for the electron, where would I most likely see it? Okay? And so the leap that is very, very hard to make is what the electron truly is that cloud. It's not what you see. You never see the cloud when you look at it. You see the electron in a position. But what it is that cloud. And people just can't. And so that's why they talk about particles popping in and out of existence. What there is this wave function, this probability cloud that tells you how likely is it you'll see a particle. And if the answer is, well, it's very unlikely, it's 0.001% chance if I look here and look here again and look here again, then when you do see it, you're tempted to say, aha, a particle has popped into existence. The reality is there was the cloud that was there all along. It was sitting there. It was not fluctuating. It was not changing, but it's not what you see. And everyone from Einstein on down has had a real tough time wrapping their heads around that.
Yeah, I still don't get it. So when people say that an atom is mostly empty space, it's not true. It's not mostly true. This...
It's a wave function for the electron, yeah.
So there's this sort of very difficult to describe property to it.
Yeah,
and that we're trying. So are we looking at things like sort of in a very material sense, like this mug is ceramic, this table is wood, and we think about the composition of it. If we cut into the ceramic, we know what it looks like. So we're trying to apply those principles to like maybe an atom.
Yeah, exactly, and they just don't apply because it's the other way around. Like we think that our world that we see every day is sort of basically how things work, and we're going to sort of translate other extremes of existence into that language, whether it's far away or way back in time or very, very small or whatever. But there's no reason to think that our everyday life experience has equipped us with the vocabulary to talk about these things in any sensible way. And in fact, it hasn't. So we have a very completely viable way of talking about the atom. We have very, very rigorous mathematical ways of describing what happens. And then quantum mechanics says what you see when you look at the atom is different. And we just sit there and insist that what we see is the real way to talk about it, no matter how anti-quantum mechanical that viewpoint really is.
That's got to be incredibly frustrating to you, because I've heard like legitimate mainstream scientists on television talking about the atom and describing it in that way.
Oh, yeah. I know. Believe me. I know. Well, and this is to be super fair, people disagree. Okay, so I think that people disagree about what the fundamental nature of quantum mechanics is. And I have no problem with that. I mean, I have a point of view, and I actually believe in the many worlds interpretation of quantum mechanics, and we can explain that. And I think it is perfectly sensible and coherent and fits together. But if you have another point of view on quantum mechanics that is also perfectly sensible and coherent and fits together, that's fine. We can disagree and we can ask about what experiments to do. The sad thing is that most physicists, especially ones that go on TV and talk about this stuff, just don't think about it that hard. And therefore, they're sloppy when they talk about it. And therefore, people come away going, I don't really get it. It's very gettable. It's totally understandable. Again, we can disagree about what the understanding will ultimately be, but physicists contribute just as much, not on purpose, but they open up the space for what the bleep do we know people to insert their woo in there, because they're not doing a very good job of measuring up to the reality themselves.
So it seems like it's something that's intensely complex that almost needs to be described with mathematics, which would require you to have a deep understanding of that mathematics to really completely grasp it. Is that a fair assessment?
Until my book comes out, yeah, that's going to be what it is.
And when is the book?
It's not. Well, so the title of the book is Something Deeply Hidden. This is a phrase from Einstein, and the idea is that there is something real that we can get a handle on. It's just different than what we see. And I don't think that we need the mathematical details to get it right. What we need is to have the willingness to let go of our intuition a little bit, to accept the idea that the way the world works at a fundamental level is very different than the typical ideas about space and time and stuff that we are born with.
Where were you when that What the Bleep movie was out? Were you a professor yet?
I think so. I lost a prospective girlfriend over that movie. Yeah. Like, we met and we went on a date, and she's like, I got the best movie for you to see.
No.
And I'm like, I don't think I'm going to like it. And she says, well, you got to be open-minded. You got to at least watch it. And I watched it. And I was like, oh, my goodness.
Did you try to explain to her that's not
true? A little
true?
bit, but there was, it was not a close call. It was not like, oh, if I explain this, she'll get it. She loved this movie. Like, this was important, right? And
I have a friend. It was a really sad sort of story. I have a friend who was really into The Secret. And she was actually a friend of a friend, more than a friend. And I ran into her at the Comedy Store, and we were talking, and she was explaining to me how she has sort of used the power of The Secret to map out her life, and it was all going to take place.
Right.
And I didn't see her again for like like a year or so later, maybe more. And then the next time I saw her, she was like, I don't understand. You know, I really thought this was going to work, and my life is still a mess, and my dad is a loser, and every guy I date is a piece of shit. And it was just like this.
Yeah.
And she just she couldn't get it right, and she was convinced that this law of attraction, which in my eyes is very similar in a lot of ways, like the idea behind it is, look, you're taking a bunch of people that are extremely successful, and you're asking them, how'd you do it? And they're like, well, I visualize it. Holy shit, that's got to be the answer.
Right.
No, that's one part of a giant thing that makes someone successful.
Yeah, and luck is an even bigger part.
There's a lot going on there. Yeah, like, did you imagine that you were born with two legs? Because some people aren't, right?
Yeah.
So when you deal with something like The Secret or something like the rabbit hole, what the bleep, there's this desire that people have to find like some secret message, like there's a magical quality to the world, and all you have to do is think about it and look about it in a certain way, and your life will take on this incredible quality.
Right. Yep. And I think that so in my last book, The Big Picture, I actually devoted, even though it was mostly about physics and philosophy and cosmology and biology, I devoted a little bit to the fundamental principles of reasoning, and especially Bayesian reasoning. I don't know if you've ever heard of Bayesian reasoning.
I have, but would you describe it?
Sure. I mean, it's basically, the essence of it is the following idea. Someone tells you a good idea, or you come up with a good idea yourself. The usual thing that people will do is either say, that sounds right, it's true, or that sounds wrong, it's false. Mm-hmm. And what Bayesian reasoning says is, no, to every possibility, you say, okay, maybe it's true, maybe it's false. I will assign a probability to it being true or false, call that the prior probability, and then I will go collect data. I will say, well, what would the world be like if this were true? And then I'll go look, right? Does this woman over here like me? Is she romantically attracted to me? Well, maybe that would affect what she says if I say hi to her, and therefore I'm going to do the experiment, right? And this is everything from going through your everyday life to being a professional scientist. So, look, fine, read The Secret, be told that there's this law of attraction. If you understand how physics works, you know that it's completely nonsense, but if you were tempted to believe it, say to yourself, all right, let me test it. Let me figure out whether it's true or false by saying, if it were true, the following things would happen. If it were false, the following things would happen. And that little, I think that everyone thinks they work that way, but almost no one really does.
Yeah, it's very difficult. We have these preconceived notions that we really like to cling to.
Yeah.
We really like to imagine that we're right about things. We hate to be wrong. And once you're on a path, like, I believe in this, it's super hard for people to shake that loose.
And people generally think that the probability something is true is either 0 or 100%. Mm-hmm. They don't like the idea that there's something is 70% true, and therefore they can sort of improve that or disprove that or whatever. It's just hard going through life thinking about probability distributions for every possible version of reality, but that is the best way to do it if you can.
Probability distributions.
Yes.
Is that what you do when you walk down the street?
Oh, yeah, totally. Long list of numbers in my head. I mean, the good news is there is a certain threshold, right? If something is 99% true or 99.99% likely to be true, get on with your life, right? Just accept that as true and don't keep trying to come up with evidence for it, against it, unless it's forced itself on you. Like when people say that the universe is not really expanding. In my field, I get this, right? Like, we've had evidence since the 1920s the universe is expanding.
Well, who says it's not?
Everyone who emails me every week like this. I get emails and letters, and they have their own theories, and the light just got tired coming from these other galaxies and so
tired?
forth.
Light gets tired?
There's literally something called the tired light theory.
Light fatigue?
Yes, exactly. And I'm not, there's some version of the scientific method that says every idea should be treated seriously, and you should sort of write down what the evidence for and against this is. But come on, I've done that. I know the universe is expanding. I'm not going to waste my time. That's okay. And that's why we can get through our everyday lives perfectly well without being very good Bayesians at all.
Have you had many flat earthers email you?
I haven't had flat earthers email me. I did once tweet. I had one tweet mentioning the phrase flat earth, and I did get an invitation to come on a podcast, a flat earth podcast.
They have a flat earth podcast?
I'm sure there's thousands, but yeah, they're out there.
Were they going to try to school you?
You know, it was, to their credit, it was quite polite. And, you know, we know you don't believe this, but let's come on and have a conversation, and we'll talk to you. And we're just about, you know, questioning things and getting at the truth. And
yeah, but they're not about getting
dogma.
an education in actual astronomy or astrophysicists.
No, the crucial thing that you notice whenever you talk to the many, many physics and astronomy crackpots out there is that they're never asking questions. Right. They're always like, here, I will tell you the truth if you want to know it. They're never like, help me learn, right? If people email me and say, help me learn, then I'm usually very happy to converse with them one way or the other.
Well, it's super easy to start questioning things, but it's very difficult to get a degree in astrophysics or to get a degree in astronomy or to just really read books about it. Like, getting through Lawrence Krauss's last book, man, there's chapters that I had to like go, okay, let's go through this one more time. Like when he came here, I had to ask him, like one of the first things we did, it was probably a mistake because it was so complex. I tried to get him to explain gauge symmetry to me.
Okay, yeah.
And it was just like, he did it like 2 or 3 times. I'm like, oh, okay, okay. I'm not, there's certain parts about it that are really hard.
Yeah.
Whereas.
I mean, we can try that again if you want, but there are hard things.
Yeah.
That's okay. You would be surprised if there weren't, right? Like if you spent 500 years learning about the universe and everything's made perfect sense the first time, that would be kind of remarkable.
No, yeah, it's super complex, and I guess that makes sense. It makes sense that it would be. Now, when someone boils it down to something that's really woo-woo, like, you know, what in the bleep do we know? But how is that very frustrating to you? Like, that must make you communicating with people that have seen that and have these ideas that are false assumptions based on it, sort of like I said to you that atoms are mostly hollow.
Yeah.
Is that frustrating? I mean, what is that like?
It's frustrating at different levels. You know, I think my first impulse is to be charmed and happy when people care. Right? When people are even interested, honestly.
Well, that's very positive of you.
Yeah, like I first want to give people credit and see if there's something inside them that we can work with and try to work toward the truth, right? But then, and I think most people maybe are like that, and there's some hardcore people who have made up their minds about the craziness. I mean, you see where it would come from, right? Because quantum mechanics says what the world is different than what we see when we look at it. So it's a small leap from that correct statement to we bring the world into existence by looking at it, right? And then you're Deepak Chopra. And Deepak he's found me on Twitter, so whenever I tweet something about quantum mechanics, he retweets it with something, but it's all in your mind, it's all consciousness bringing the world into existence.
He loves word salad.
Yeah.
That guy is the biggest dealer of word salad that the world has ever known.
And the genius is putting the word salad into a recipe that people think is nutritious for them, right? they really like to eat, even though there's no actual nutritional value.
Well, you get a lot of that from like certain yoga classes. Like there's certain yoga classes that I go to where like the yoga teacher will start talking some woo-woo shit and like you're be in the middle of the pose. And you're like, what in the fuck is this guy going on about, man?
I do it too. And as long as the pose is helping me, I'm going to put up with that.
Yeah, I'll smile my way through it. I'm
not going to debate them right in the middle of.
But it's weird that stuff is all that's all sort of kind of in that sort of genre of people that are trying to improve their life or be spiritual, or they love that Deepak Chopra shit. Like I had this conversation with a friend of mine who's like he gave me a Deepak Chopra book. And I started going through it, and I was like, this guy's crazy, right? Like,
right.
He probably wants to do well. Like, he's probably not a terrible person. He probably wants to do well, but he's also ignoring the actual scientists that study all this stuff. Yeah. And he's sort of pitching this thing that what it is, like this Deepak Chopraism, this sort of like spiritual, pseudo quasi-spiritual view of the world that he's pitching to like these middle-aged housewives that are like looking for some sort of meaning to life, but they don't like going to church.
Yeah, and Daniel Dennett, the philosopher, came up with a great word for it. He calls them deepities, when you string some words together in a way that sounds extremely profound, but you look closely at it and it doesn't actually mean anything at all.
There's a website that'll do that for you.
Oh, the Deepak Chopra quote generator. Yes, that's right. It's not that hard. I would like to laugh, but there's another website that comes up with random physics paper titles. And it's not that different.
It's not that different.
You can usually tell when it's a random physics paper title.
But the physics stuff it's almost, I guess there's similar issues with the reason why Deepak can do that is because most people don't understand what he's talking about. So if you say a lot of stuff about things that people don't understand, like there's been a bunch of videos that we played on this podcast about fake martial arts practitioners. Right. There's a whole business in these people that have these fake martial arts techniques, and they use all these huge words that are very, very rare about the central nervous system and about the structure of the body, and they'll use all this stuff to try to get you to think like, oh well, this guy obviously has an enormous vocabulary and a deep understanding of anatomy. He must therefore be this chi master that he's pretending to be. And it's kind of very similar. So I kind of recognize that pattern in the woo-woo people. I'm like, oh, I kind of see what you're doing. You're throwing a bunch of very complicated words that aren't in most people's vernacular, and you're saying them in a way that makes me feel like you have some sort of a connection to the chi and to the chakras and to the inner whatever that everybody's trying to reach to be happy.
Yeah, and another problem is just that whenever there is a field, whether it's physics or medicine or whatever, where we know something, but it's hard, complicated, counterintuitive, when we explain it, we translate it, right? In physics, we have mathematical equations that are quite unambiguous as to what they say, but then we use words. We say, well, there's a cloud, there's a probability, etc. And every translation is inaccurate in some sense. So if you're basing your beliefs off the translations, then you can fudge them a little bit more to get almost wherever you want to go.
Oof. You confused me more. I was good with the cloud up until now. Why is it a cloud? Like, why, when you're describing where the electron inhabits, why is it a cloud?
Well, it's if you're thinking about the electron, what the wave function is, sort of how we use it is, you ask the question, if I were to look for the location of the electron.
Right.
There's a machine that tells me the answer. There's a probability of seeing it here with a certain number, a probability of seeing it there, a probability of seeing it somewhere else. And so at every point in space, there's a number, the probability you will see the electron there, right? Mm-hmm. And so if you visualize all those probabilities all at once, it looks like a cloud that is filling up all of space. And then the leap is to say, there's no such thing as where the electron is. There's only the cloud. It's not like the cloud is expressing your ignorance of where the electron really is. The cloud is what there really is. And I sound exactly like Deepak Chopra, right? There's no way.
No, you don't. Bohr versus electron cloud? What is
it? Oh, yeah, here we go.
Well, it's the visualization of it.
Hopefully it is. That's right. Yeah, so on the left, this is the picture we like to draw. Electrons orbiting around as if they were little planets in the solar system. On the right is closer to reality, but you see even there, they couldn't quite resist the temptation to make it pointillist and little dots.
Yeah.
And it really should be some smooth distribution. This is what the physicists would call the thing on the right the wave function or the quantum state of the electron. And it is that cloud, and it answers the question, what's the likelihood that we see it in different places? The hard part to mentally get to is the cloud is what is real.
Is it almost like what we're looking at here with all these dots here, and it says, Jamie, go back to where it was at, please, where it says the probability of the density of the electron, and then you see all those dots. Is the issue like making a visual representation of it, almost like if I asked someone to draw a visual representation of a thought?
Yeah, it's something like that, exactly, because we're used to stuff. Coffee cups, bottles of water, like they have locations in space, they have a shape, a size,
but
things
we believe
like that.
In thoughts.
Yeah, exactly, but it's hard to draw them.
Right. Where's that going? Where the hell's that? I mean, that's the most important thing that we've ever had when it comes to the creation of civilization, inventions, innovation, creativity. All those things are just thoughts, and draw a thought.
Right, but we're familiar with those, right? Thought? We're intuitive. We get that, what you mean. If you say it's hard to draw a song, right? But okay, I know what it is.
Well, at least you can draw the musical notes.
You can, but it's
sound.
And so if you talk about an electron, that's supposed to be a thing.
Right.
It's supposed to be somewhere that I can find it. And someone comes along and says, no, nature is totally different than that. And you will never in your life be able to see with perfectly clear eyeglasses what nature is really like. They get a little annoyed, but it's the truth.
What do you think about the very uber bizarre theory that the universe is incredibly fractal, in the sense that what we're looking at when we're looking at the universe is essentially some sort of subatomic particles for a much larger atom, and then it goes bigger and bigger, and then there's a human out there
that's
also a part of another galaxy, that's also part of another universe, it's also a part of another atom, that's also... Right. No?
I get it, but no. I think that the closest thing that is a little bit more reasonable to that... Well, so let's go the other way around.
Yeah. Let me ask you, why is it no?
Well, so... Let's go the other way around.
Okay.
Let's ask if maybe what we think of as atoms could be alive with like little people and substructure that we just don't know about. So if you're an honest, conscientious scientist, you always say we don't know for sure, right?
Okay.
But everything that we think we know about quantum mechanics says that things like electrons and quarks are completely featureless. That if you tried to put little wrinkles and make them different, like the Earth and Venus and Mars are very different from each other. Every electron is exactly the same as every other electron. And if you tried to give it any distinguishing features, it would cost an enormous amount of energy that's just not there. So there's fundamental principles of physics that says that there are no people living on atoms, okay? And so what we're like with our solar system, even though it kind of vaguely resembles an atom in some sense, we are nothing like real atoms. We could not be packed together to make a solid object in this bigger world or anything like that. So our existence is sufficiently different from the subatomic realm that I see no way that we could be the same thing as the subatomic realm to some bigger people. I do think we could be living in a simulation, as Elon Musk famously suggested. We could be all living in a computer simulation. I don't think it's likely, but it's completely plausible given what we know right now.
Right. The real issue is that one day we most likely will have something. As long as technology continues to exponentially advance, we'll one day have something that's indiscernible from the reality. They'll be able to interface, more than likely.
Yeah.
They'll be able to interface with your senses, with the way the mind perceives reality, and create something that passes that uncanny valley and literally feels like real life, like the Matrix or
I think
whatever.
that we might be very far or we might be pretty close. I think it's hard to tell because there's so much we don't know right now. It's not like this is coming in the next 10 years.
But it could be 1,000 years.
But yeah, absolutely. And that it could, the thought experiment that helps people accept this is, a single neuron in your brain. You have something like, 100 billion neurons in your brain. But every single one is not that complicated. It takes in some inputs, it puts in some outputs. It might be work to figure out exactly what it does, but it's not mysterious, right? So we can imagine replacing one neuron in your brain with a solid state micro device that does exactly the same thing as that neuron. And you would be the same person, roughly speaking, right? Mm-hmm. So if you believe that, then do that with two neurons and do it with 3 neurons. And you're gradually building up who you are, but just replacing your brain with something that is machine-made. And if you believe that can happen, there's no reason to think that machines can't be as human as we want them to be.
Do you follow any of Ray Kurzweil stuff?
A little bit. I don't think that he's an especially deep thinker, but he's a good provocateur.
How dare you? He's right now pounding on his desk.
That could be.
This motherfucker. You don't think he's an especially deep thinker? I mean, he's a brilliant guy. He's invented a bunch of really fascinating things.
Yeah, he likes to extrapolate without limit pretty fearlessly.
Well, he must have irritated you for you to jump right out with, I don't think he's a particularly deep thinker.
No, but I do think he serves a role. I think there are people who make us think more deeply, right? Mm-hmm. Like, I remember seeing a panel discussion with Murray Gell-Mann, who was a famous physicist, and Isaac Asimov. This was like 30 years ago when Asimov was still alive. And there was someone else who was on the panel, I forget it was, another physicist. And the amazing thing was, the science fiction author was by far the most conservative thinker up there in terms of what he thought would really be happening 1,000 years from now, right? The physicists had these way out ideas, and Asimov was like, I don't think it's going to be all that different, right? And it's just hard to predict the future accurately, and there's a role served both by trying to be as realistic as possible and careful and Bayesian and saying what are the probabilities and so forth. And there's another role served by just being the provocative and saying, well, maybe this crazy thing is going to happen. Maybe we'll cure death in the next 100 years, and life will change for everybody dramatically.
That seems fairly likely, right? They're going to figure out some way
plausible.
to reverse aging.
Yeah, I think that's plausible. There's no biological reason why not.
Kurzweil's got some weird motivations, too. He literally wants to sort of rebuild his father.
Yeah.
Yeah. He wants to be able to piece together some sort of an artificial intelligence version of his father and go back and see him.
Yep.
That's deep.
That's a word for it, yeah.
Yeah. That's he thinks that there's going to come a time inside his lifetime, hopefully, that you'll be able to download consciousness. That consciousness is going to be something you'll transfer, sort of like code.
Yeah, I think that there's a difference between what is potentially possible given arbitrary amounts of time and resources, and what is realistic in the relatively near term. By the near term, we mean 50 or 100 years, right? And I think that people like Ray Kurzweil are far exaggerating what's going to be possible in the next 50 or 100 years, because they underestimate how little we know about how the brain works, how important it is for the brain to be in our bodies, right? Mm-hmm. One of the breakthroughs in artificial intelligence over the last couple of decades was to realize that if you try to build an artificially intelligent computer, it becomes much more realistic if you give it a body, if you give it a face and it can interact with people. I mean, we underestimate the extent to which having a body is an important part of how we think and who we are. And this is just like such baby steps in understanding this stuff, that to imagine that in the matter of decades we'll have it all figured out and have downloadable consciousnesses is not realistic to me.
Do you think that we have to absolutely understand the exact way that the human brain works in order to replicate its possibilities?
No, I mean, I think that we probably won't. That probably won't be the way that we make artificial consciousness or artificial intelligence. Like, we won't just be reconstructing human beings. Mm-hmm. Like, when we made cars, we didn't reconstruct horses, right? We just did it in a very, very different way. And cars are much better than horses in various ways. Not as good in other ways. Like
going up hills. Going
up hills, but also in the early days of cars, one big complaint was, but if I'm drunk and passed out, it won't take me home all by itself, right?
Is that a complaint?
Yeah, that was a complaint, and
that's
it's true.
That's hilarious, because the horse would just take you home and knows how to get there.
Exactly, and finally we'll get the artificial.
And nobody gets mad.
Self-driving cars will be able to do it finally.
If you're driving a horse drunk, nobody gives a shit.
No, you're passed out. That's right.
That had to be like a big adjustment for people.
Yeah, exactly.
No more driving drunk.
And so the idea that the way that we'll make artificial intelligence is to sort of mimic a human being is just crazy. No, that's not how it's going to be.
What do you think it's going to be like?
Well, I don't know. There are the problems that can be solved by things that we design are just a different set of problems than the thing that evolution naturally made us do, right? Like, evolution built a very, very general purpose machine that is inefficient and irrational in all sorts of ways. Like, anyone's pocket calculator since the 1970s can multiply numbers way better than your brain can, right? Your brain has enormously more computational capacity than a pocket calculator. Why can't we multiply numbers? That ability was not important back when we were evolving these things, right? So the set of things that it is easy to design is just very, very different than what the brain does. So who knows? I don't know exactly what it will look like. I actually think that the more important thing will be blurring the distinction between human beings and machines, the crossovers. There's another one of Elon Musk's project is called the neural link. The idea of, basically a neural lace, something that is just interfacing with your brain very, very, very fast so that you have access to the entire internet or whatever peripherals you want in real time. So like Wikipedia is part of your memory, essentially, and that's just who you are and how you walk around. And you can multiply numbers as fast as you want to.
That seems like very likely.
Yeah.
That augmented reality.
I think that's coming, yeah.
Yeah. And some sort of a weird symbiotic connection to the net and to electronics, whether it's a wearable thing or maybe even an embedded thing.
Yeah, absolutely. I think it will be embedded eventually. Think so? Yeah, it's just more efficient.
Will you be one of the first adopters, or are you going to wait a little while?
I'm never a first-generation adopter even of iPhones, much less things embedded in my body. But look, I just adopted 2 kittens. They get microchip implants. Right?
Oh, yeah.
When you adopt a cat, it gets a microchip inside so you can't lose it.
Yeah.
And so to think that we're very far away from doing that, I don't think is right. I think that we're going to be doing things.
I was just looking at a laptop bag, It's a laptop bag that also is, you have a passport bag and a laptop bag and then a carry-on and then a check and stow, for airplane luggage. And all of it is Bluetooth and all of it is location coordinated with GPS so that if somehow or another your bag gets lost, you literally can go on a computer and it'll show you where your bag is.
Yeah.
It's like, whoa.
Yeah.
Like, how long are we going to, when are we going to do that with people?
And I feel, I'm a big believer in privacy rights and so forth.
Her dilemma. Do I let my employer microchip me? What is this?
There you go.
There's a company in Wisconsin that had microchip day on August 1st, and they implanted microchips in people.
First of all, that dude with his ears and those fucking earplugs in the lower ear lobe thing, you ain't doing nothing, buddy. You ain't sticking that in me. Look what you've done to your ears, fella. Wisconsin company becomes first U.S. employee. What?
And these are very simple, just location tracking things, right?
Yeah, but why would you allow the company to do that? I wouldn't allow my company to tattoo me. Why would I allow my company to microchip me?
It's for tracking, and you can also, they can buy stuff in the cafeteria and whatnot.
Yeah, you know what else you could do? Use your wallet.
You say that, but
gross.
Do you turn off all cookies when you have your laptop on in your browser?
Yes, I do. No, I don't.
You don't, because it's a little convenient.
Yeah.
And these guys say they can buy their snacks with their microchip. They just walk up to the machine and get a snack.
But here's where the separation
every
is.
loss of
This
privacy.
laptop, I can go like that, and then I can walk out the door, and that laptop stays here. And all the cookies and all my browser history stays here.
Mm-hmm.
It doesn't. It's not under my fingernail.
That's just what they want you to think. Yeah.
Oh, Jesus. Now you're freaking me out. Another thing I wanted to talk to you about with quantum mechanics that came out of that movie, What the Bleep, that was very confusing to a lot of people, was the whole observer effect. Now that is something that I've tried to explain to people, that the issue is, well, please, if you could explain it. Like, this is, the thing is that people believe that in quantum physics, it's been proven that if you look at things, that you looking at things changes those things. But the way it's been described to me, it's like, no, it's actually because you are measuring those things, and that's what changes it, the act of measuring it.
Yeah.
And that there's some sort of a physical interaction when you're measuring something. That's what's changing the effect. Is that correct?
Right. Yeah, I think that's right. This is a legacy of the bad old days of quantum mechanics when people were a little bit fuzzy about these things. We're beginning to get better at it. The bad old days, yes.
I thought you said like battle rap.
I don't think they were battle days. Maybe. I'd like to see Einstein and Bohr going at it. Rap battle.
The bad old days.
Bad old days,
when people had a more limited understanding of what quantum mechanics really is.
And spoke about it in slightly sloppy ways.
Okay.
So there is the truth that if you want to describe what you see when you look at an electron, what you see is different than what it is. Like you do change it by looking at it. And therefore, back in the bad old days, a lot of people wondered whether there was something special about consciousness or human perception or something that was helping us explain the laws of quantum mechanics. So as you are pointing toward, no, the answer is no. There's nothing special about quantum mechanics and consciousness in any way. A rock could do the same thing, or a video camera, or a speck of dust. The quantum mechanics rules says that things change when systems interact with each other. The way that you describe a system is different when it's all by itself than when it interacts in some interesting way with some other system. And that system can be a person, but it can be anything else also.
So in that famous experiment that's in that cartoon that gets passed around by people every 2 or 3 years, when they're like, wow, the world's made of magic, and they pass this around, it's usually a yoga teacher. They that shows that there's the particles and the waves. Do you remember the video? See if you can find that video.
Yeah, no.
See if you can find it. It's Dr. Quantum. Will we get in trouble playing that? Maybe if we're shitting on it, we will.
Yeah,
They get mad at us. We might get pulled. We get pulled from YouTube.
You had a good run.
Well, people, they own these videos, and so it's a real issue is wildlife videos.
Yeah.
Those suckers, they're so quick to pull the trigger, and they have a claim. It's their video.
Yeah,
so if you use
put work into getting it. Yeah.
So if you use it and mock whatever is happening, or even if you tell them, hey, go watch this video, it's on YouTube, here's the name of it.
Right.
You would think that would be like good advertising, but no, they get you yanked.
Here, I'll bring it up and we can talk about it a little bit.
Okay, so give me some volume so I can hear what this dude is saying.
I think this is from What the
one
Bleep.
you're talking about, right?
Yeah, that's exactly it.
Yeah.
The Double-Slit Experiment.
Right.
On the back screen
See.
shows that intensity. this is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now, there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum.
Okay, now you're gonna freak out.
Okay.
This is where you start getting mad. They're going quantum.
An
Okay.
Going quantum, I know.
is a tiny, tiny bit of matter,
Ooh.
like a tiny marble. Let's fire a stream.
He gets
through
already
one
shaking his
slit.
head, folks.
It's not a tiny marble.
We gotta do a little bit of commentary on it. We can't just play the whole video.
Right.
Okay, I can do the. I know exactly what they're talking about. It's a
Okay.
very famous experiment. So, yeah. So if you have two slits that you let marbles go through, they get two slits in the receiving screen on the other side.
Right.
Whereas if you let a wave go through two slits, you get this interference pattern.
Right.
And so what happens when you let an electron go through? The answer is you get an interference pattern. It's more like a wave than a particle. But the real weird thing that they're going to get to eventually is if you let an electron go through two slits, but you put little detectors on the slits. So you say which slit did the electron go through? Then it always says it goes through one or the other. It never goes through both. And the interference pattern on the other side disappears. You only see the two lines that you would have seen if they were marble-like. So the point is when you're not looking, the electron is acting like a wave. And when you look at it, the electron acts like a particle.
Right.
That is the lesson of the double-slit experiment.
Right. Why?
Why? Because when you put that detector on the slits, you interacted with the electron and you localized it, right? There was no such thing as the position of the electron. There was no such thing as the answer to the question, did it go through one slit or the other? There was only a cloud. There was only a wave going through. But you affected it, or whatever the detector was, affected it when it looked through the slits to see, did it go through this one or this one? And that effect changed it from being going through both slits to being only going through one.
And how does it affect it like that?
Well, it's what's called quantum entanglement. The detector becomes entangled with the electron. And this is where you get into my favorite version of quantum mechanics, which is the many worlds interpretation. The right way to think about the electron was that cloud, that wave going through. That's the natural thing. The weird thing is that when you look at the different slits, you only see it go through one or the other, and it acts like a particle. So how do you explain that? So in other words, our natural intuitive way of thinking about electrons is as particles, little marbles, and quantum mechanics says, no, it's naturally a wave. The weird thing is when it acts like a particle. And if you're a many worlds person, what the answer you give is the following. When you look to see, did the electron go through one slit or the other, you, or whatever video camera you had or whatever, becomes entangled with the electron. And what that means is that the wave function of the whole universe, the wave function of both the electron but also your camera and you and the stars and galaxies and so forth, splits in two. And there's now one branch of the wave function which acts like its own separate world, which says the electron went through the left slit and your camera saw it go through the left slit and it made a little line on the other side. And there's another branch which says the electron went through the right slit and your camera saw it go through the right slit and it makes a line on the other side. And so they're both still there, but the world's split in two and now you're only in one of them. You don't see the whole world anymore.
You managed to make it more confusing. Congratulations. You screwed my head up even more. I understand it less now. That's even more baffling.
But the bit you understand is actually true. That's the improvement.
Well, it's so little.
The illusion of understanding doesn't count.
Oh, okay. So by not understanding, I understand more.
Exactly. There you go.
Boy.
Quantum
You
motto.
have a weird job, dude.
I do.
It's a very, very weird job. But I get it now, though, in talking to you, why you have the Deepak Chopras of the world and why you have like the what the bleeps, because it's so intensely confusing.
Yeah.
And especially with the limitations of language, of just...
It's counterintuitive. It's against every little bit of our everyday experience. It's a set of concepts that we're not equipped with, that we're not born with, that we have to struggle to get into our heads over many, many years, and it shouldn't be surprising.
So you, as an educator, when you're talking to people about this, it's obviously you've probably done this thousands of times, right? And tried to have these kind of weird conversations with people like myself that sort of lack the tools to really truly understand what you're saying. What is that like? I mean, it's got to be frustrating in a sense, or no?
I love it. Yeah,
you do.
I do. Yeah,
oh, that's great.
I do, because
what a great attitude.
I was there. That used to be me. Like, it's not like my brain was born ready to understand quantum mechanics.
Mm-hmm.
I worked at it and struggled with it and got it wrong. And who knows? Maybe 10 years from now, I'll think, oh, I was so stupid 10 years ago, right? But I think that it can be understood. I think that people who want to try to understand it, number one, are already 90% of the way to being awesome. And number two, the remaining 10% is very, very achievable. It is understandable.
Wasn't it Feynman that said if you think you understand quantum mechanics, you don't understand quantum mechanics?
He said something like that. He said he can safely say that nobody understands quantum mechanics.
Yeah.
Which is fine, except that you should therefore be outraged. You should not be proud of that, right? It's not a badge of honor.
He was kind of a funny guy.
Oh, yeah, he was being funny. And I think that it's certainly true that we don't understand quantum mechanics if by understand you mean both understand and everyone else agrees that you understand it. Right? Maybe someone understands it, but certainly there's no consensus on the right way to understand it.
No consensus on the right way to understand it is a very disturbing concept to people like me.
Yeah.
We want you to say, well, water is wet and oxygen is this. And that's this is what wood is.
I think 1,000 years from now, historians of science will look back on the 20th century and shake their heads in despair. They'll say, look, you guys, quantum mechanics fell into your lap and you didn't spend any time thinking about it. You didn't try very hard to understand it. That's embarrassing.
Really?
Yeah.
Like the general public or scientists?
No, professional scientists, people with PhDs in theoretical physics.
Wow. So when it comes to the people that you were talking about, like scientists who sort of dismiss quantum mechanics, what are they dismissing and how are they doing it?
Well, to be very, very clear, they're not dismissing quantum mechanics. They use quantum mechanics every day. They love quantum mechanics. Quantum mechanics is a recipe for calculating what's going to happen in your experiment that is of unprecedented precision. It's really the best way we have of knowing what's going to happen in the lab that we've ever invented, and there's no reason to think that it's wrong. But then when you press them on, okay, what was really happening? What is the description of reality that corresponds to the calculation you just did? They get annoyed and frustrated with you rather than giving you an answer to the question.
How so? Like, they get annoyed and frustrated with you? Like when you have these conversations with these people?
Yeah, with anyone. Yeah, they will. You will
because
hear
they don't understand
physicists. Well, they don't understand, which is fine. But they act as if not understanding it is okay. And to me, that is not fine. They will say, my job is not to understand the world, it's just to make predictions. And I think that's not really the job of science or physics at all.
Their job is not to understand, it's to make predictions. Well, how can you make predictions if you don't understand what you're making a prediction about?
That is exactly the situation with quantum mechanics right now. Like, we have a recipe, we have an algorithm, a set of rules, do this, do this, do this, you get an answer.
Right.
And the answer is right. The answer is verified in experiments over and over again. And you say, well, okay, why is it right? What was happening? What is the thing that is moving around? And they go, I don't know. Don't ask me about that.
That's hilarious. Now, what do you do most of the time when you're not teaching?
Right.
So, like, if you're working on this stuff, like, I would imagine there's not someone telling you what to do, right?
No,
so when
not at all.
when you're working on this kind of stuff, like, how do you structure it?
Yeah, it's up to you. There's a sort of a selection effect that the ability to structure it on your own is necessary to get to a certain stage in your career. But I have students, graduate students who I work with, as well as other colleagues that I collaborate with. But it's roughly speaking going into the office or going to a cafe, sitting down with a piece of paper and a pencil and writing. That's what I do. That's my job.
You go to an office or a cafe, and you sit down with like one of these yellow legal pads, and you write all that chicken scratch that nobody understands but you guys.
Yep. I've recently changed. Now I have an iPad Pro with an Apple Pencil, and I do it on that.
Oh, you do all that.
I've only very, very recently upgraded. But
maybe you can get yourself one of them Samsung Note 8s that has the pen on it. Have you seen that? It's the
I've
new
not
one.
seen that.
Oh, it's pretty badass.
Really?
You can, while the screen is dark like this, you don't have to turn the screen on. You pull out the stylus, and you can draw notes on the screen.
Okay.
Up to like 180 pages of notes.
Yeah.
Like on the actual screen itself. You don't even have to open it up.
All right, that's pretty cool. But now I'm invested.
cool.
Now I got the iPad, so
I know. That's how it
works.
works, right? But the difference is you can carry that around in your pocket.
Yeah, I know. That is a difference.
Yeah.
But
the
idea is that, there's a set of questions in our brains as professional physicists. There's an infinite number of questions, but at any one time you're focusing on a couple. And you have a couple of ideas, and so you say to yourself, well, maybe if things are like this, then this would follow, and let's try to calculate what that would lead to, and does that lead us someplace good, or is that just crash and burn? And that's what you do over and over again until you get a paper you can write.
And where do you start from? Like, what is like say you get to the cafe, like what's your starting point?
Well, so for example, let's do quantum mechanics, right?
Okay.
So we want to understand the many worlds interpretation of quantum mechanics.
Okay.
So you say that the world really is some quantum wave function, but you and I observe things like space and tables and stuff like that, right? So what does that mean? What does it mean to say that there's a table lurking in the wave function of the universe, or there's stars and galaxies? So that means that there's some way of writing the wave function of the universe that is sort of, here's a table, here's the rest of the universe. So I might write down on a piece of paper, well, here is a toy model, like a simple representation of the wave function of the universe that includes one piece and another piece, and they're interacting with each other. How would I know that that was table-like? Or how would I know, tables are not really what we care about, but why is space three-dimensional, right? This is the kind of question we would worry about. So what would a wave function look like that represented three-dimensional space? Is that natural? Could I poke at it, and could I make a prediction for what the early universe was like on the basis of that? Things like that.
So now, like, when you do calculations, like, say if you were doing a calculation, do you study black holes at all?
A little bit, yeah.
A little bit.
Yeah, writing a paper right now on black holes.
Are you?
Yeah.
And what are you writing about? Like, what specifically?
Well, there's this famous problem in black holes that they evaporate, right? They give off radiation. Stephen Hawking, back in the 1970s, said that black holes weren't completely black, right? There's quantum mechanics says they will gradually evaporate away. So that's fine. We think we understand that.
What does that mean?
What does it mean? It means that
they're not completely black. Like what a black hole is essentially, like the event horizon is this tiny, infinitely dense area,
right,
and it's sucking in the galaxy around it. And like supermassive black holes, is it still believed that they're in the center of every galaxy,
yep,
and they represent 1/2 of 1% of the mass of the galaxy itself?
Yeah, tiny fraction, right.
So the larger the galaxy, the larger the supermassive black hole.
Basically, yeah, that's right.
So what is it?
So what is the black hole?
What is it? Yeah.
A black hole is a region of space. It's a region of space where the gravitational field is so strong that you can never leave that region of space to go to the outside world.
Jesus.
That's what it is. But so Stephen Hawking, so there's different sort of levels of sophistication in thinking about what black holes are. So one level is to forget about quantum mechanics entirely. Use general relativity, Einstein's theory of gravity that he invented 100 years ago, 1916. And he says, what is gravity? It's space-time curving on itself. That's what gravity is. And he has equations to tell you how much space-time curves, etc. So we can describe black holes in those terms. And one of the things you find is that black holes only ever increase in size, right? They can suck things in, but they never shrink because they just suck things in.
Right.
But then in the 1970s, Stephen Hawking says, well, what if we take into account quantum mechanics? There's these clouds of probability all around the black hole. And he says, if I look at a black hole, does it look completely black? And the answer is, to his great surprise, and still to ours, no, it doesn't look completely black. Even black holes, when you look at them, will be seen to gradually emit photons, to emit radiation very, very, very slowly.
And how are you looking at them? Like, what method are you using?
This is a thought experiment. We've never seen this in the real world. The actual black holes we know about emit radiation so slowly that there's no practical way to actually observe it. So this is entirely theoretical right now.
So, but if it is entirely theoretical, how do you measure that they're not entirely black?
We haven't been able to do that. We predict that they're not entirely black, but we've never verified that prediction yet.
You're freaking me out, man.
Yeah. Well, there's a lot of physics is making predictions that we can't yet test, but someday we're hoping.
But why even assume that? I mean, I don't understand what the motivation for assuming that they're not entirely black is.
It's not an assumption. It is if you believe what we think is already true about general relativity, the curvature of space-time, and quantum mechanics, then Hawking says it follows from those assumptions that black holes are not completely black. They give off radiation.
Okay. Now, what about the theory, and then I've heard this fairly recently, that there is potentially another universe inside of a black hole, that as you go into a black hole, you may in fact be going into another universe that's filled with hundreds of millions of galaxies that have hundreds of millions of black holes at the center and perhaps hundreds of millions of universes inside of them.
Right. It's possible, which again, as I said earlier, is what you should always say in these circumstances.
Right.
There's no reason to think it's likely, but it's certainly conceivable that that happens. By the way, the journey would not be pain-free when you went inside the black hole. You would die, okay? You'd be very, very, the technical term is spaghettified.
Right.
Because the gravitational pull is much stronger at your head than at your feet as you're diving head first. So you would be pulled into a very thin, non-living...
What if you cannonballed it?
Yeah, that doesn't help. Doesn't help.
Did you go crazy when you saw that movie Interstellar? Were you
I didn't go
screaming at the
crazy. I
screen?
think, it was a weird thing. I actually know a lot about the backstory there because Kip Thorne, who invented the idea, is my colleague at Caltech. So if you remember the movie or the book Contact, Carl Sagan wrote back in the day?
Loved that movie.
So Carl Sagan was a brilliant guy, but he was not a physicist. He was a planetary scientist. He studied life on other planets and things. So in his novel, he had this idea. He wanted his heroine, Ellie, to get across the galaxy very, very quickly, faster than the speed of light. And so in the first draft, he said she falls into a black hole and then she gets spit out somewhere else in the galaxy. And he knew that's not exactly right. That didn't sound right.
Right.
So he called up his friend, Kip Thorne, who's a very famous physicist at Caltech, who, by the way, will be winning the Nobel Prize in a couple months in October.
Is it rigged?
No, but it's just such an obvious choice because he also helped invent LIGO when they discovered gravitational waves, and that's definitely going to be worthy of the Nobel Prize.
LIGO?
LIGO, yes.
What's that?
Do you remember hearing that gravitational waves were detected a year and a half ago?
Yes.
So LIGO is the observatory that did that.
Oh, okay. So
Right.
that's the observatory. Something
He was
put together.
one of the moving pieces, moving forces behind that.
So gravitational waves were some theoretical thing that's now been proven to be real.
That's right.
Big announcement about the new gravitational waves from LIGO might be coming. Yeah, that was August 24th. That was pretty
Posted
recently.
an hour ago.
Oh.
Yeah, I don't know what it is.
Ooh, so there's another announcement. What is it? Tell us. Can you tell us?
Let us know.
I can tell you because it's on the internet. You can see
scoop.
it. I don't want to tell you because I should let LIGO tell you, and this is a rumor. But
Okay.
I would just say stay tuned. When we saw last year, the announcement was black holes were spiraling into each other and giving off gravitational waves, and that's what we saw. Okay? That was the source of the gravitational waves that we saw. This news story is about neutron stars spiraling into each other or spiraling into something. I don't even know the details. It's just a rumor. But it's a different source for the gravitational waves than we had before.
Here it is. Beyond black holes, could LIGO have detected merging neutron stars for the first time? Now, merging meaning at like this infinitely slow pace that you're sort of measuring.
No, but it's very fast.
Very fast.
Yeah, it takes seconds once they're
they're together.
Yeah, once they're very, very close and emitting gravitational waves you can observe.
Wow.
And the exciting thing is, once black holes can merge, why not neutron stars? The difference is that black holes, despite everything I just said about them not being completely black, are pretty darn black. So you see gravitational waves, but you don't see them in your regular telescopes. With neutron stars, there's a chance you can just see them as well as detect the gravitational waves.
Now, neutron stars, when they're doing this, we're talking about like how far away are we observing this?
Oh, I don't know. Usually millions of light years.
Wow. So anything you're observing happened millions of years ago.
Yep. That's right.
Jesus.
Yes.
That's one of the bigger mind fucks. It's hard to get your head around when you're looking up in the sky and you're seeing something that's a million light years away.
Yeah.
When you're looking through a telescope, you're seeing something that might not even be there anymore.
Oh, yeah. Well, in this case, it's not because what gave off one of the biggest explosions in the universe. And that's what you're seeing the aftermath of. Yeah. So those neutron stars are no longer around if they're that. They might have made a black hole. There might be some black hole remnant.
Wow.
Over. Yeah.
Have we observed the birth of a black hole before?
I don't think we've observed the birth. We've observed one big black hole being made out of two smaller ones. That's what
Really?
LIGO saw, right?
They actually observed it taking place.
Depends on your definition of observe. We know that it happened, from the gravitational wave signature that we observed.
Okay, so you have a signature that is undeniably the evidence of this
Now,
thing.
this one, I don't know the details here with the neutron stars, but there they might be able to say there is now a black hole left behind. I don't know. I'd be surprised. That sounds very precise, very unrealistic, but that's the kind of thing we would hope to be able to say someday.
I've seen that on drugs, this thing that you're showing. If you take DMT, you can see that.
Uh-huh.
So what is this? This is the animated depiction of these two black holes spiraling into each other and becoming...
This is
That
Rana
guy-
is another one of my Caltech colleagues.
That dude needs to get outside.
Yeah.
He looks like he's just been buried in books.
Then we wouldn't get good physics if
I
those people
know.
went outside. Don't let them outside.
A little bit.
Stay inside,
Just
Rana.
about a little bit, buddy.
Yeah.
Just get outside a little. Look at him. He's just,
These pictures don't make themselves.
I'm sure. No, I'm sure they don't. Look at, he's got this fish on the wall. He's losing his mind. He's drawing fish. When you try to make these visual representations of something that is like essentially you're only interpreting, you're getting the gravitational wave, you're getting the information, the data, and then you try to make a visual representation of this thing. That's for the general public, right? It's not
Basically,
not
yes.
really for you guys.
That's right. So if you could also, though, see the event happen using visible light or using your regular telescopes, that would give you enormously more information. So that's always a good thing to aim for.
So as they do like this this array that they're putting together in Chile and all these different new, more advanced super telescope arrays, they're trying to get more and more actual visual information so that people could see this stuff or something.
Yeah, I mean,
bizarre.
there's a lot. It's much easier to detect light than it is to detect gravitational waves. So
this is the sound.
Is that
this is the
sorta how they
actual
did it?
gravitational wave from the early detections, the first ones we got last year.
So this is LIGO Hanford on top and LIGO Livingston. Is this the actual sound?
There is no actual sound. They translate it into sound. This is a gravitational wave that they said, well, what if it were a sound wave instead of a gravitational wave? This is how it would sound.
So confusing. I was watching a documentary, and they were talking about hypernovas.
Okay.
And they were talking about the initial discovery of hypernovas, that they detected this gamma radiation, these bursts in the sky, and they originally had one working theory that there was some sort of an alien war going on.
Yes, right? Oh, yeah. We
Yeah.
always do that. Like, astronomers, bless their hearts, they, are happy to at least contemplate some of the more way out speculations, like when pulsars, which are just spinning neutron stars, when they were first detected, they were called LGMs for little green men, because they were these very, very regular pulses, and people said, what could it be? Aliens.
Right. It's
It
sort
was
of like,
not.
like one of those planets that we've observed recently had something that was orbiting it, and they were trying to figure out if it was some enormous space station that was causing this.
Well, there's something that got labeled the alien megastructure.
Yes, that's it.
Which is basically like something that is bigger and colder than you would expect, but maybe if it were, some structure surrounding a star, that's what it would look like. And
yeah.
I wouldn't bet on that. I don't think that's the reasonable thing
Well, whenever
to
I read
guess,
something
but
like that, I'm like, oh, they just want funding. They just want to get people excited.
you don't get any funding for that.
No?
You anti-get funding for that.
For an alien megastar?
Yeah, because the people giving you funding are your fellow scientists who think that you're
Oh.
just taking cheap thrills
Right.
rather than being serious.
So what you do is you get hits for your website.
Exactly.
And you might not necessarily, like when you're going to some of these websites that, science websites for the most part have really straightforward sort of titles to their articles, but occasionally you get a little clickbaity
Oh, yeah.
with some stuff. I mean, it's a good
We're
way.
human. They're
Yeah.
human beings. They would like a little more, little likes on their tweets.
Juice it up a little bit, get people excited. Yeah. So when they first initially discovered these gamma ray bursts, and they thought that there was some sort of an alien war going on in space, so far, nothing, right? So far, there's no detectable evidence whatsoever of anything out there other than us.
That's right.
But when the thing, if there is, I mean, when and if, right? If the thing comes, if one day we get some sort of undeniable signal, whatever it is, or we see something, or how does that get processed? Like, do you have to go like straight to President Trump and go, hey, man?
I would not do that. No, that's not what I would do.
Well, who is like, say if it was one of your colleagues.
Yeah, though there is a procedure. It's not even very well publicized as far as I don't know.
Is it a legal procedure? Is there like a
I think it's more self-appointed. I think it's like, people have said, all right, we are the alien detection network.
So you might be able to keep your mouth shut if you like people can't handle this shit.
Yeah. Well, I think that we're not very realistic about these. I think that it could happen, but we're just like with quantum mechanics or artificial intelligence or whatever, we tend to put everything in the frame of what we're immediately used to.
Right.
So we can beam out radio signals into space. We're really good at that, right? So we tend to think that aliens will either be discovered or actually contact us by beaming radio signals at us.
Right.
But that's a horrendously wasteful way to do interstellar communication, right? For one thing, radio waves move at the speed of light. So imagine you're 1,000 light years away. You have no idea what's going on Earth, but you say, well, it's a promising location for life to arise. I know what I'll do. I'll beam a signal at them. Well, how long are you going to beam it? Are you going to turn the telescope on for a month? Then in the whole history of humankind, they better be listening at the exact right month, otherwise they're not going to hear it. It's actually way more efficient to send a spacecraft, even though it's much slower. That's okay. You have plenty of time. Send a spacecraft and park it in the system that you want to know about, and then wait for life to arise in that system. So honestly, if we're going to detect evidence for aliens, it's much more likely we're going to find a monolith on the moon or something like that than we're going to hear them in our telescopes.
A monolith on the moon. Wasn't
that
that something?
Was a 2001.
Right. But wasn't that something that one of the astronauts said they saw something up there? Some of those astronauts have lost their mind as they got older. And I've always wondered, like Edgar Mitchell was the big one. He's the one who says he's seen some things and says that aliens are real. Yeah. And I always wonder, are those guys getting crazy as they get older, or they're going, look, I got to get some money. I need some attention. What's the best way to do it? Yeah. Tap into that alien market. That alien market's a big market.
They could be perfectly sincere, but look, you want, when you pick who's going to be an astronaut, is someone who can fly the spacecraft back, right?
Right.
They don't need to have good judgment about whether or not there are aliens up there. Right. That's not what you're going for.
Right.
So.
They just need to have an understanding of what the task is and how they're going to perform it.
Yeah.
Yeah, Edgar Mitchell was, I think he might have passed away recently. Did he pass away? But he's one of those guys that people always bring up. But I'm not a believer necessarily in, not that I'm not a believer in alien life, but I'm not a believer in any of the people that say they've seen aliens or I did a show for Sci-Fi, and one of the episodes we did, we spent weeks talking to people that are UFO researchers and studying the air quote evidence.
Right.
And there's nothing there.
Yeah.
Like,
look, be a good Bayesian. If someone sees some flashing lights in the sky, what is more likely? Alien civilizations, or they're not accurately reporting what they saw? Like, eyewitness testimony is terrible.
Terrible.
And especially in these weird cases, it's just very, very dismissible. So
right, and you want to keep an open mind, because if there was a unique event where an alien spacecraft did enter our atmosphere and observe us and then take off, it would be quite fascinating if you could actually get a good read on someone.
I think it'd be hugely important to the history of life on Earth, right? Like human history. If and when we finally discover intelligent life out there somewhere else, that'll be one of the most important events in our history. The idea that it's a 20-foot long flying saucer that comes and visits you in Wyoming is not very plausible to me.
Well, also the idea of physical beings on board this thing seems counterintuitive. Like, why would they do that?
Yeah.
Like, we don't have to do that anymore. Like, we send the Mars rover up there, we get amazing footage. It stays up there forever. It doesn't need food.
Exactly.
Yeah, it's not
So that's
dying.
what they'll do. They'll send a rover here.
Yeah.
Not either a person or a radio wave.
That's what I would imagine. I would imagine it would be, obviously, I don't know what the fuck I'm talking. So if you're getting mad right now, I get
You're
mad
the
at me too.
You're the voice of the aliens. That's okay.
I would just assume that it would be some super complicated drone.
Yeah.
and that
I think that's right.
Yeah, they would try to just take data, observe, maybe get some sort of a visual understanding. And obviously, with the kind of telescopes that we have, like the Himawari 8, when they 22,000 miles out, we take these incredible high-resolution, detailed video and photographs of the Earth itself. What kind of shit do the aliens have?
Right.
They probably don't need to get anywhere near us, right? I would imagine.
And the weird thing is, the Fermi paradox. Mm-hmm. They should be here already, right? Like the solar system should be buzzing with these drones, and either, almost certainly it's not, because it's not clear why they would try to hide from us, really. And if they don't try to hide, they'd be easily noticeable. So there's something we don't understand about life in the universe. Either it's much more rare than we might guess, or for some reason it's not very gregarious. It doesn't go and visit the rest of the stars in the galaxy.
My thought was, and this is obviously a very controversial thought, but no one wants to think that we're the first, right? That's like, well, if there's us, then there's probably more.
Right.
Maybe, right? But maybe it has to happen once. It has to happen for the first time somewhere.
Yeah.
Right. Like like a single-celled organism had to become a multi-celled organism. It had to take place through mutation, and it had to take place at one point in time. Well, that time on this planet, at least, it was the first time. One point billions of years ago. Right. Why do we? We know that we are the only thing that's ever done that, as far as we know here. So why would we assume that anything else? We might be the tip of the spear.
It's completely possible, I think, and it's also possible that that life happens all the time, but it never becomes multicellular or intelligent, right? Or it becomes intelligent but never builds spaceships. There's many ways it could happen. But yes, we could be in the entire observable universe the only spaceship building species right now.
Well, we also have this weird way of defining intelligence by the ability to change your atmosphere, or your environment, or your to build things. Like, that's what we think of as intelligent. Whereas dolphins are obviously extremely intelligent, but they don't really impact their environment much at all, other than biological life, like eating things and waste and things along those lines. But they don't build structures. They don't keep records. They don't.
And we live on a weird planet that is roughly, a comparable proportion of land to ocean, right? It'd be very easy to imagine planets that were all ocean, that the dolphins were the apex predators, and that was it, right? And so
they just
would
got
never
really
build
smart,
spaceships.
really good at eating fish.
Yep.
Yeah.
And they played games and whistled songs, and that was great.
Yeah. Well, also the idea that life only has to exist in this Goldilocks zone has always been weird to me.
Oh yeah, that's very strange. Also, we're already finding exceptions to that, right? Like even here in the solar system, you wouldn't necessarily look to Earth first if you didn't already know. The moons of Jupiter and Saturn are very plausible places to look for the beginning of life, even though they're outside the Goldilocks zone, because it's just different conditions. So I think we should be very, very open-minded about the conditions around other stars where life could form.
Yeah, I mean, we find weird life at the bottom of oceans and volcanic vents where it's insanely hot, and they find these life forms that are able to thrive in those conditions that would kill almost everything else.
Yeah. And part of that is, I think that the response to that would be, well, life started in fairly benign conditions and then evolved to survive in these harsher conditions. But I just think that our ability to understand chemistry and biology is not that good, especially hypothetical, speculative chemistry and biology. We should be very humble about saying how life needs to be on other planets.
Right. We always assume that it has to have water and it has to be carbon-based. And
maybe that's right, but we can't say that we know.
Right. Did you ever go through a period in your life where you were obsessed or fascinated by aliens?
Yeah, when I was a kid, I certainly, not only aliens, but psychic powers and all this stuff. I was very, interested in all the cool stuff. And I became more and more scientific as I aged, and here I am.
Yeah, those are weird things that are somehow or another linked together, because I don't want to be mean in saying this, but they're bullshit. Or psychic powers or aliens. And when you bring up the fact that it's very likely these things are bullshit, people get very upset. Like you're taking away their Santa Claus.
Yeah.
You're...
I don't know. There's a video I saw literally this morning on the web of these people stood outside a little mart on the corner of a street in New York where people were buying Powerball tickets. Okay, so the people buy Powerball tickets, and it's like $10, and they come out, and they were offered, "Can I buy your Powerball ticket from you for $20, for twice what you paid for it?" And 11 out of the 14 people asked said, "No, I'm holding on to my ticket," right? Because they thought that this ticket was the winner.
Right.
And they're like, "This is $700 million that I'd be giving you for $20, right?" With no rational justification. But they, it's in some sense innocent. If you just, you're wishful thinking about your own little ticket, that's fine. But it leads us to be not completely rational when planning our futures. Yeah.
I'm with the people that won't take the 20. You got to roll it. Come on. I mean,
you can go in and buy 2 more tickets.
Yeah, but the 20 would just be 20. It would just be $20.
No, you can go buy more tickets.
Right, but you might have in your possession the ticket.
Or it might be the next one that gets
But what
sold.
if you give it to them, you give them the ticket, you get the 20, you go buy some useless tickets, and it turns out the ticket you gave them was $700 million. You're going to jump off a roof.
And what if the one you buy is the one that wins?
You're a glass half full kind of a guy, aren't you?
The probabilities work out. It doesn't really matter. You don't know what the number is going to be.
Right, but the randomness of it all is what gets people like panicky, right? Like, what if? What if?
It does,
but
yeah.
It could be.
I mean, the best way to calibrate your odds of winning the Powerball or saying, just play the numbers 1, 2, 3, 4, 5, 6, and people will go like, well, that's never going to come up.
Right.
And you're like, actually, the probability of that coming up is the same as any other one that you're going to pick.
Huh.
Doesn't matter what order.
Yeah, it's just random. Now, have you ever read anything compelling at all that leads you to think that maybe somebody might have observed something that could potentially have been something from another planet or some sort of an...
No, I don't think so. I mean, I think that astronomers do have a set of things that they don't understand very well. The most recent example are these things called fast radio bursts, which are a little bit different than the gamma ray bursts. But, as always, the more we think about it, the more we say, oh, actually, I can come up with a perfectly plausible explanation for that. That has nothing to do with aliens. Going back to the sort of uploading consciousness thing, there's a very real possibility that once civilizations or intelligent species become sufficiently advanced, they upload themselves and they realize there's not really any motivation to go exploring in the universe and maybe die anymore.
Yeah, that's what my thought would be, that once civilizations get sufficiently advanced, they would go virtual. They would figure out some way to create these artificial universes to travel into that are probably just as complex, if not more.
I think we have every right to imagine that, given that we know so little about what it would be about right now. Yeah.
Well, if we can create artificial intelligence too, that's what's very bizarre. Is like, if we can create artificial intelligence and somehow or another corral it into existing only in this virtual world that we've created, and then inside this virtual world, you're interacting with these artificially intelligent creatures that are disembodied, right? And then in this world, you would give them some sort of a body, and you would interact with them.
I think that, again, the thing that we underappreciate about that is, what is the motivation that these artificially intelligent entities would have? Like, we human beings, like it or not, we get hungry. We want to have sex. We want to have power or whatever.
Right.
But, like, if you're just a virtual being in an environment without these energetic constraints or need to eat and sleep and so forth, why do you do anything at all? I don't know. I mean, I have no idea what the psychology would be like for something like that.
Did you see Ex Machina?
I did not.
How dare you? That's an amazing movie. I saw it twice. I think I saw it 3 times. It's really good. I mean, it is a very balanced take on potential artificial intelligence and someone making it.
I should see it.
Really well-made movie. But you see the sort of, I don't want to give away too much of it, but you see the struggle in these things as this guy is interacting with these things. And you see the struggle as they're trying to interpret what they are versus what he is.
But they are in bodies, right? They're like robots?
Yeah. Yes. Okay. Yeah.
Yeah.
Got to wonder, like, Elon Musk is terrified of this shit, right? I mean, he said that we might be summoning the demon. That's his exact quote.
Yeah. Yeah, and I get trouble. I tend to agree with him. And again, I get in trouble on Twitter for saying that I agree with him. But because people who are actually doing artificial intelligence have this very real appreciation for how far away we are from something that you would classify as intelligent in any real sense. And so therefore, from their day-to-day perspective, the worry about super intelligent AIs taking over the world is laughable. But my argument, I think Elon's, is that, but what does the percentage chance have to be that this is going to happen before you start worrying about it if the consequence is really the ruination of the world, right?
Right.
I mean, there are only so many things that we do for which the worst case scenario is quite that bad. That's what makes it a special circumstance. And it might be very, very unlikely. But are you willing to say, like, okay, 1% chance that all human beings get destroyed? I don't think that's actually the worry, but we should just do our due diligence, right? We should think about what the possibilities are. We should plan for them. Probably no big deal. When I said this on Twitter, people, knowing that I was a physicist, were like, well, what did you think about people who were worried that the Large Hadron Collider was going to destroy the world?
Right.
And I said, well, what do you mean? Physicists did many, many studies checking to see whether or not it would destroy the world. We don't want to be destroyed any more than anybody else. And so I think that's a very sensible thing to do for artificial intelligence also.
Yeah, I agree. It's just when you see articles like, did you see the recent article with the Google AI that they had to shut down because they were starting to communicate with each other in some sort of a language they invented?
The language was not very convincing if you ever saw it printed out.
I'm sure. But to me, that's like a scene in a horror movie. Right. Where like, and then you go to 10, blank screen 10 years later, and we're all dressed up like Mad Max with fucking bandanas over our face, and we're running from Terminator bots.
Well, I think that's the thing. Again and again, we're coming to this theme that our imaginations are not quite up to the task, because our imaginations about superintelligent AI are something like that, something Frankenstein-esque, just in robots, or something like out of Asimov. But I think much more realistic worry are things like currently existing neural networks and deep learning algorithms. So basically, there's all sorts of problems like pattern recognition, facial recognition, right? We are very, very bad at sitting down and writing a program that recognizes faces. Human beings are not very good at figuring out how to do that. But we have ways of building programs that can teach themselves to recognize faces, and they're amazingly good. So we have programs like when you go onto Google or your iTunes or whatever, and your iPhoto is recognizing your face. There is some neural net that is doing that, and there is no human being alive that understands what it's doing.
Jesus.
All we know is that it's getting the right answer. Okay? And that kind of logic can go very, very far. And so I'm not worried about like a robot like Ultron taking over. I'm worried about all of our infrastructure being run by programs that no human being understands.
Whoa. That's something I hadn't even considered. But yeah, that's a real issue.
Yeah,
a real
that's
potential issue.
It's a real issue, right.
That's an actual real thing. I've always wondered whether or not what human beings are doing with our insane lust to innovate and to constantly create new and more spectacular things and to always look for the next version of something. I mean, we're not satisfied with the iPhone 6. We want the iPhone 7. We're not satisfied with that. When's the 8 come out?
Yeah.
And we have this intense desire for better things. We don't... I mean, unless you're a classic car advocate or devotee, really what you want is like, oh, this new car, it stops faster, it handles better, it accelerates quicker. We always want things to constantly improve. And when you look at human beings, like if you looked at us objectively, that's one of the main things that we do. We produce better technology, better objects, better engineering. It's like constantly improving and accelerating. Mm-hmm. And then there's this potential artificial intelligence thing. I've always wondered if that's really what our focus or what our purpose is on this planet, that we're like some sort of an electronic caterpillar. That it's going to become a butterfly, that we recognize in some sort of a weird way, or nature recognizes the biological limitations of flesh and tissue, and that it can advance far better with something that we create, so that we don't even realize what we're doing by making this cocoon, that we're just like building it up, and we're not even thinking about what we're doing. We're just, I want a new laptop, woo! Right. And by buying this, and by this materialism that we all have, right? We have this people have this innate sort of desire for new and shinier objects, that is fueling this innovation, and that's pushing along this, and that one day we're going to give birth to this new version of life. We can call it artificial life, but it's not artificial if it's right there. It's just created by human beings, which obviously are created by this intense and very long evolutionary process. Right. This might be a part of that process.
Yeah, so I would tend to want to remove from that the sort of anthropomorphic or teleological aspects of the language, like that it's a purpose or we're meant to be here. But I completely agree with the idea that there's a threshold that has been crossed, whether you want to say it's the last 500 years or the last 10,000 years. Human beings have developed the ability to do something that has never been done before. And that has this sort of recursive, self-reflective thing that we can build things that can build things, and we can build things that can learn, and we can build things that are like living things. And we are just at the very, very beginning of exploring the space of what's going to happen because of that. And the idea that we human beings are going to be around 10,000 years to enjoy the fruits of that, I have no idea whether that's true or not. I don't even know if that's bad. I mean, maybe it'll still be human beings. Maybe 100 years from now, we'll cure death and aging, and we'll stop having kids, and the people who are alive 100 years from now will live for another 1,000,000 years. Maybe human beings will just become more and more melded with artificial things, and they'll have artificial bodies and so forth. Or maybe, another underappreciated thing, I think, is that at the very, very small scale where we do like nanotechnology and so forth, there is a whole bunch of problems that have already been solved at that scale, namely biology, cells, right? Like cells do many, many things really, really well, and they also repair themselves. They're much less brittle than things that we build using metal, okay? So synthetic biology, just programming existing biological organisms or designing new ones, but we would still recognize them as biological, but they might be very, very different than anything that naturally appeared through the course of evolution so far. That could be the thing that takes off, and 100 years from now, that's all the living beings or all the beings with higher intelligence left on Earth. I mean, I don't know what the actual thing that's going to happen is, but what I know is that the pace of change is just accelerating. We're just at the very start.
Yeah, we really are. And it's so, do you ever sit around and try to extrapolate and try to like look at where we are now as opposed to where we were at the turn of the century? And last, 20th century, and just try to think and like, where is this going? I mean, it seems like any day now, some new invention could be put forth that changes the way we interface with reality.
Right, and it's subtle because it's not uniform, right? It's not like it's a weird fact. If you wanted to make a movie and set it 50 years ago, right? So in the 1960s. It wouldn't be that hard to film, outside and in certain areas, certain suburbs. It kind of looks more or less like it looked in the 1950s. Whereas it actually would be harder to make something that was in the 1960s look like it did in the 1910s, right? There's sort of more obvious, visible change just because cars were different and so forth. But you don't see the sort of technological change that might have a far bigger impact in electronics and artificial intelligence and so forth that happened in the last 50 years. So just because there's no visible sign of the change doesn't mean that the changes cannot be eventually very profound.
It's always amazing, too, when you look back at like science fiction movies from like the 80s where they were predicting 2017, they thought we were going to be flying around in space constantly. Like the movie Alien, what year was that supposed to be? I think that's like the year 2100 or something like that, right? It's not that far.
Yeah. Well, what we're really good at is taking things that already exist and extrapolating them to be faster and bigger.
Yeah.
Right? So if you can build an airplane, then you can build a rocket ship arbitrarily fast. That's easy to imagine. But things that change culture, like really curing aging, that's hard to imagine what that would be like.
It's also greedy. Because, like, where are we going to put all these goddamn people if they live forever? If they live forever and everybody has 4 kids, we got a real problem on our hands real quick.
Kids.
No more?
No more kids, no.
Damn,
clearly.
Dude. Do you have kids?
No.
Well, that's why you say that.
But I'm not going to live forever either. If I did have kids, then maybe their kids would live forever. But, that's the thing. That's the size of the change in society that would be required by something like that.
2122. That's when Alien takes place. That's 100 years from now. Get out of here. There's no way.
Could be.
Meanwhile, they had some shitty monitors for 2122. Right. I mean, God, they were terrible.
Terrible one,
Yeah, but the inside of the cockpit for Mother, when that dude gets in there and finds out that, there's some
it's hard
giant
to extrapolate far into the future, right?
Oh, yeah.
It's really, really hard.
Yeah, I think we're more likely looking at some sort of augmented desktop sort of scenario. Like, have you seen these new products like that Microsoft is working
Right.
on and some of these other companies?
But I think before very long, it won't be a desktop. It'll just be our thoughts.
Really?
We'll just, like I remember what I had for lunch, I'll remember what the population of Malta was in the year 1500.
What am I looking at here, Jamie?
This shitty cockpit.
Which movie is this?
Yeah.
Alien.
This is the first one?
That's what it said. I mean, that's what I was Googling. It could have got tagged with something else, and I didn't recognize it, but
Huh.
Tesla
pretty,
looks more modern.
That's
than
pretty
that.
good looking.
looks
pretty
like it
good.
too.
No, that can't be the original Alien, is it? I think that's like Alien 2 or 3.
Nostradamus, yeah.
Is
This
that,
is
the,
Alien.
is that the first one?
The second one you clicked on, yeah, that's
Yeah, they look pretty badass. Here.
Nostromo.
Nostromo. What I meant was there's a white room that I forget the actor's name in the original Alien. The original Alien, people don't even realize was in the 70s. It seems crazy.
Yeah.
Sigourney Weaver ages very well, by the way.
Just saw her. What was it? Oh, The Defenders. She was
Yeah.
in, yeah.
Because she was in that movie. She was probably in her 20s back then. But that movie in 1979, like their idea of what 21, 22 was going to be like, they had like weird lights flashing in the cabin that didn't really seem to make a lot of sense, but they looked electronic.
Actually, these might have been pictures from the new Alien.
Yeah, that's what it looked like to me.
Yeah, because it did kind of look like a Tesla in there.
Here's
Yeah.
It was weird because they're kind of...
screen thing. This is like from the actual production set.
Oh, yeah, that's the new one.
Yeah.
See, because they're kind of saddled down by the problem that they're replicating a film, that was from the 1970s, and they
But
might
look,
be
they have
sort of
these
saddled
big
down by the
levers that look like you're in an airplane.
Yeah.
It would not be like that.
tech. You don't think so?
No, it's going to be in your head. You're
think
not going
so?
to need buttons.
Yeah.
Buttons
So
are
even
very-
navigation will all be
I
in
think
your head.
I think we live in the only generation that's going to get repetitive stress injury from poking at our devices all the time.
Really?
Yeah, that's the most useless thing in the world. It's a very slow, inefficient interface. Typing
Hmm.
on your cell phone a text message.
I hardly do it anymore. A lot of times I'm talking to my phone now.
It's very old-fashioned of you. All right, very retro.
No, using voice recognition software.
Oh yeah, okay, right.
That's retro? Was
People used to
what you
use
meant,
their
or
phone
what did
to-
you mean?
Well,
Make
people
notes?
used to make phone calls.
Oh, I do that too. I'm a crazy phone call person. But the text function,
Right.
the voice recognition function, is really amazing.
Yeah,
do you
I don't
use it at all?
I don't use it as much. I'm,
it's-
like I
it's
said, a
crazy.
slow adopter, but yeah.
Look how good it works. I'll show you right now. It's really pretty interesting. We can click on this, right? There's like the notes thing. This is
Yeah.
how I do a lot of the stuff. Like if in my car
Yeah.
and I have an idea that comes to me, I'll either record it, like with the voice recording function, or sometimes it's better to do this. And when you're doing this, it essentially can pick up everything you're saying in real time and print it out.
Yep, they got it right.
That's amazing, right? Bam.
It is.
I mean,
Yeah, and
everything perfectly spelled. What I just said, folks, is now on my phone. Amazing. What is this?
Yeah.
Seen these? These are the new. I don't know how well they work because I've only seen them out in like commercials and whatnot. But real-time in-ear translations in French, Spanish, English. I've seen Chinese, Japanese.
Oh, I've
Yeah,
seen
It's
that.
the size of an earbud.
Yeah,
They're not
I've
that
seen that.
expensive.
So again, once you have the link inside and you just interface with your brain, then essentially you will speak every language.
$129. That's amazing. So you can go. Is it called Babelfish? That's what it's called.
This
It's like it.
like it.
Oh,
That's from.
That's
a
not the
movie.
name of it. I
Yeah,
know,
no.
but that's not the name of it.
Yeah,
What is
yeah,
it? What's the name of it?
This one I've just have now. It's from Waverly Labs. It's called The Pilot, I think.
The pilot.
This is pretty awesome, though. The
That's
idea that you
amazing.
could just go. Is Japanese one of them?
That on this particular one, I don't believe so, but I'm 90% sure I've seen videos like on Facebook showing a Japanese one.
I'm planning my first trip to Japan, and that'd be very, very useful.
Japan's amazing.
Yeah, I've never been there.
What, you going to go to Tokyo? Where are you going to go?
We are flying. There's a conference in Fukuoka, and then we'll visit Hiroshima and Osaka after that.
Oh, wow.
Kyoto, hopefully.
I went to Japan a few years back, and it feels like you're in a super polite alien world.
I'm very happy. That sounds good to me. That sounds
It's
fun.
It's beautiful. They're very
Yeah.
polite. The food's amazing.
Oh yeah,
This
there
one
we
does
go.
even more. It's
Wow.
called 1-to-1, and it
Using
uses
Watson.
to do more languages than I just said
Wow.
before. Portuguese.
Scroll up so I can see what
So
that
look,
looks like.
so Watson is an
Whoa.
example of one of these programs which learns things and we don't know how.
Right. Okay.
Right.
That's a problem.
And now it speaks Japanese and French. So
Yeah. So this one is how does it wear, Jamie? What do you? It says Bluetooth and Wi-Fi. Out of the range of Bluetooth and Wi-Fi, translate 1-to-1 can still work just as well. as the first device on the market for language translation using AI that does not rely on connectivity to operate. It offers significant potential for its unique application across airlines, foreign government relations, and even not-for-profits working in remote areas. Whoa, that's crazy. So it's different than the pilot earpiece. How do you wear that sucker?
Looks like it over your head.
It's probably just like a hearing aid. It'll probably just look like that, and they'll probably be big now, just like they used to be in the 80s.
Right now.
And it'll eventually get smaller and smaller.
This would not be sexy while you're wearing it, but
yeah, unless you're into that stuff. It was saying that you download language packs,
so you can be off the internet.
Yeah, so it'd be like there's these map applications like Onyx Maps and stuff like that. You can download. Like sort of a Google Earth type topographical map of areas, and you could look at it. Say if you're hiking, you could look at these on your phone, even if you don't have cell service. You could just pull them up and get a Google image of like, oh, hey, here's the creek that we have to go down to get water. Yeah. Nuts.
Yeah.
It's getting super slippery. $279, and you can use that sucker.
Right now.
That's right now. That's amazing.
That's add to cart.
Don't do it.
It takes 3 to 5 seconds to translate.
Woo!
Most languages, it says.
There's a thing called Google Lens, which is pretty amazing, too. I used this when I was in Italy. And you take your phone and you look at something through your phone.
Oh, right.
And it translates it on the screen,
yeah.
which is amazing.
Yeah.
Like, you're looking at a sign, and you hold it up, and it'll tell you what the sign... Like, we were at a train station. I was like, what the fuck does that sign say?
Yeah.
You put your phone up there with the Google Lens, and it'll translate it to
I know, I
English.
use that. The only problem was, like, for menus, it's like, what is this? Oh, it's Rosa's Chicken. I have no idea what that is. Really, but yes.
Right, yeah. Well, fortunately or unfortunately, when you go abroad, Americans travel so much, and so do English people from England, I'm sure. But it's such a common language. Most of the world can speak English.
That's right, yeah. We definitely have an advantage.
It's huge. In Italy, I mean, it's like you barely need to understand anything other than saying thank you and saying, hello and good evening, things along those lines. Buonasera. You can get by. But.
Yeah, the first time I went abroad to a foreign-speaking country was France, and I was just too shy to talk to anybody because I was not in Paris. I was like out in the middle of nowhere where people did not speak English.
Ooh.
And by now I even had like read the phrase books and things like that. But by now I've just done it so many times I don't really care. I'll try to speak my 2 words of the local language and then try to switch to English. And if it doesn't work, it doesn't work, and we just do hand gestures.
When you travel to a place like France, people have this. French people in particular, there's always the stereotype that you hear that French people think that Americans are rude.
Right.
Like I would try to go way out of my way to make sure that no one thought I was like a rude American.
Yeah.
Because there's always this reaction that they have. Like the worst case scenario is the American goes over there and is pissed off that they don't speak English, and they start.
I don't know. My first trip, I was treated very, very well in France, very, very politely. I bought something in a store and I didn't understand what the price was. So I just sort of kept giving money until they nodded. Mm-hmm. And by mistake, I had given too much. And the guy ran out after me to catch me leaving to give me my money back.
Oh,
right?
That's nice.
And that was uniform, except in transportation industries. Like whenever I wanted to buy a plane ticket or whatever, that was very, very hard. Ironically enough.
Were they rude or were they just difficult?
Really tired of dealing with tourists, right? So,
right.
I would say in French, do you speak English? And they would say, of course I do, in French.
Right.
I'm like, okay, well, then can we do that instead?
Yeah, they're probably just exhausted.
They're just exhausted.
But that's how it is in America.
Yeah.
I mean, you deal with
totally.
people at the airline counter. They always have this look in their face like, what time is it? When do I get out of here?
I don't blame them, yes.
Yeah, that's the
I get
problem
that way
with
too. Yeah.
doing something you're not passionate about. Unlike you with your legal notepad, writing alien languages in a cafe somewhere.
It's a great privilege what I do for a living, right? Like I can't believe that I get paid to do this. And it's hard. I have to tell my incoming graduate students, if you get a PhD in theoretical physics from Caltech, and you probably want to be a physics professor, because that's the only thing you can do with that degree, and your chances are maybe 25% of
That's pretty damn good.
It's good, but after you're like 26 years old and put in a lot of work,
right.
It's to still only know there's a 25% chance of succeeding.
That's still pretty amazing. I mean, if you're trying to be a stand-up comedian, your odds are like 1% if you're lucky.
Right. No, the very, very good thing about academia is it's very clearly up or out, and you there's time limits. Like if you haven't succeeded by now, You're gone. You can't,
Really?
you can't
So what
hope
do you
to be
do?
discovered tomorrow.
Damn.
You usually go to Wall Street and make a lot more money.
Oh, so he said, look, I'm a
If you get a
smart guy.
PhD in physics from Caltech, you're not going to starve, right?
Oh.
People will hire you to do something.
Interesting. So what would you do on Wall Street with a PhD from Caltech? in
These
physics?
days, all the money is being made by algorithms that study the stock market and destroy human beings picking stocks, right? Renaissance technologies and places like that. I mean, so, like we were just talking about, but soon the entire stock market will just be dueling algorithms, trying to sell something a microsecond before something else does.
Now you are involved in a hard science, right? I mean, you're involved in this trying to understand the world and the universe itself. Do you see any of the identity politics issues that are going on campuses today? I mean, it's such a hot subject. Whereas
you see a little bit. You know, my job at Caltech is research professor, so I don't even teach a lot of courses, to be honest. And Caltech is not a typical campus in many, many ways. But, you know, we just had a professor who was basically fired for harassing students. It does happen.
sexual harassment?
Yeah. That's
Trying to get laid?
It wasn't quite. It was more complicated than that. He fell in love with a student and fired her, and it was all kind of a mess. There's just no question that, you know, I'm in an area, theoretical physics, where there's a very tiny fraction of women, an even tinier fraction of African Americans and so forth. But that's kind of less surprising because they just don't come up usually in economic circumstances that put theoretical physics as one of the plausible future research careers. But you know, I see an enormous amount of discrimination against women in my field, and it's there, and women leave, and some of the complaints against it are overblown, but many of them are very, very real. So that's a real problem for us. I think it's changing. I think it's fixing, but it's slow.
What kind of discrimination do you see?
It's these days, it's usually very subtle. It's usually you're taken a little bit less seriously if you're a woman. I mean, there's all sorts of tests that have been done, right? Like people handed out mathematics papers and then all they did was change the name of the author. James Smith versus Jennifer Smith. And they were always ranked much worse when it was Jennifer Smith who was the author, even if it's exactly the same paper.
Really?
And you know, there's a certain style of aggressive, in-your-face egotism that serves you well in academia generally and in physics in particular, putting yourself forward, asking questions, being loud and noisy. And women are less good at that for whatever reason. They're not trained to do that, or it's innate, I have no idea. But they can sort of get bullied into silence or just say, like, this is not worth it. I'm going to go do something. I'm going to go to Wall Street to make money.
Also, a woman who does that is not likely to be received as well as a man who does that. A
Yeah,
woman
exactly.
who does that
It's
is
held against them.
Yeah, they're deemed to be like a bitch.
Yeah, so like
Versus
my
a guy who's
floor
aggressive.
at Caltech, I'm on the 4th floor of a building, which is the theoretical high-energy physics group. So there's maybe 30 people total, professors, postdocs, graduate students. And until this year, there were 0 women out of 30, which is just embarrassing. It's just bad, right?
Yeah.
And who would want to be the one woman who went there, right?
It would be gross.
Yeah.
Yeah, but man, but you know, especially there's two, like men either who think they can have sex with you or men that can never have sex with you.
Right.
Those would be both annoying.
Yeah,
And then
and-
like if you're lucky, you get a guy who doesn't want to have sex with you, just wants to be your friend, and then whew,
That's
you're
right.
all right.
Yeah.
But
And I think that, you know, honestly, if I were giving advice to young women whose primary goal was to become a successful theoretical physicist, you know, if that was your only goal, then don't raise a fuss about sexism or discrimination, because just like worrying about the interpretation of quantum mechanics counts as points against you when you're being judged as a theoretical physicist, worrying about discrimination against you counts as points against you. People think like, oh, you're not really interested in physics, you just want to make a political fuss. And
wow,
so
that's unfortunate.
keep quiet. Yeah.
I mean, I know that what you're saying is pragmatic, but a lot of people don't want to hear that. Like, keep quiet. They
Well-
don't want to hear keep quiet when you tell women to, when you're talking about discrimination.
Right.
Or,
So maybe your only goal in life is not to personally become a successful theoretical physicist. I
Right.
mean, just as my advice is not keep quiet. My advice is, if that's your goal, the way to achieve that goal is to keep quiet. Right?
God, that's gross, though, right?
It is, and so I think that it's kind of the job of guys to raise a little bit of a fuss about this. And I saw it at Caltech where this guy recently got fired. How many people were willing to make excuses for his really, really, really bad behavior?
Right.
It's unseemly to talk about these things. We hope it's not true. Like this is our friend. This is someone we worked with. We don't want to believe this about him. We want to protect him. So. Physics, philosophy, astronomy, all these areas are now having these examples of famous big-name professors that it's finally being revealed for the last 20 years have been regularly harassing graduate students and pushing them out of the field. And I think maybe finally that's coming to light enough that it's hopefully will go away a little bit.
Human folly. It's interesting. Yeah. It's a lot of like what we were talking about earlier with the people that don't necessarily understand quantum physics, and so they sort of dismiss what's important about it, or people that just use they rely too much on ego, or it's too much of a part of their life. I mean, the human folly that sort
make
of
excuses and
gets involved in everything.
And I'm not. The broader question of identity politics, et cetera. I mean, I'm pretty lefty justice warrior about this stuff, to be honest. I think that the number of women, for example, women are just the most obvious example in my field, who have been pushed out of my field because of bias and discrimination in very, very obviously, verifiable ways that's the big embarrassment, But at the same time, I'm kind of a free speech absolutist. If some crazy person who has very retrograde views wants to say those retrograde views, then I think that if someone else wants to invite them on campus to do it, I think they should be allowed to say all the craziness that they want. I don't think that's the right solution to these problems.
Yeah, I think the solution in those cases is for someone who's got a legitimate viewpoint to debate them.
Yeah,
the marketplace of free ideas.
Actually, the chancellor of Berkeley just put out a very good statement saying exactly that, and I give her credit for that.
Well, that's great, because I know that they have an issue there with Ben Shapiro coming, who's a very reasonable guy and sometimes gets lumped into the alt-right and gets lumped into these. He's not that at all. He just happens to be conservative and young and very articulate, but for a while they were trying to limit his participation there and putting him in the same category that they would put Milo Yiannopoulos or some of these other guys there, which... we're very weird with free speech in that we love free speech as long as it's in line with how we think.
Easy to defend free speech for people we agree with.
Yeah,
that's right.
Yeah.
I mean, I don't know Ben Shapiro, but Larry Summers is another example. He gave this famous speech at Harvard. He was the president of Harvard and a world-famous economist. And he gave this speech saying, well, maybe the reason why we don't have as many women physicists as male physicists is because of a different distribution of innate abilities. Now, I think that you could make a very, very good case that his substantive claims were entirely bullshit. Like, he misread data and he was making excuses. And it's one thing if that's a guy on the street. It's another thing if it's the president of Harvard. Okay.
Right.
But then after that, people were saying, well, he shouldn't be invited to give talks about economics at other universities because he said this bad thing. I think that's ridiculous. He's a world-class economist. He was wrong and you should criticize him. But I want to hear what he has to say about economics. That's something entirely different.
Isn't it also there's an issue with someone who's a professor who's constantly used to really not being questioned and giving lectures and being able to talk in front of students, and you develop sort of a general hubris about your own opinions? Is that possible?
Well, I would hope that, I don't know, in my areas of academia, you can't get through lunchtime without having all of your opinions questioned all the time. That's just what we do, right? You never sit around and say something and everyone agrees.
That seems like a very healthy profession.
Yeah,
then.
that's how to make progress. But of course, usually we're talking about the wave function of the universe or the nature of the dark matter, right? And to be very, very fair, there's, like we said before, there's still prejudices about purely physics topics. You can talk about quantum mechanics or the nature of the dark matter, and discussions get very, very heated and emotional, and people's jobs depend on it and the whole bit. But the idea that things go unchallenged is not, that just doesn't fly very far in this field. Yeah.
Well, that's beautiful. I would love to talk to you about what you just said, dark matter.
Yeah.
Because that's something that I would imagine if you went out and just randomly polled 1,000 people, all 1,000 would have no idea what dark matter is.
Yep.
That maybe it's like part of the universe. Like it's really, we can't find it, but it's
what
there.
Was it? I think it was Rick and Morty recently that had a silly episode about dark matter.
What is Rick and Morty?
It's a cartoon, Cartoon Network show. It's a hilarious, silly thing that uses science fiction conceits to do
actually, I've seen that.
things.
Okay,
Yeah.
I think I know what you're talking about. I've seen.
I mean,
online
dark matter
clips.
is real. It exists.
Yes.
Okay.
How do we measure it?
We measure its gravitational force.
Okay.
It pushes things around in the universe.
So what do we think it is?
We don't know. That's the thing. We know certain things about it. We know that it's dark. We know how much of it there is. It's about 5 times as much mass in dark matter than there is in ordinary matter. Ordinary matter is every particle we've ever seen ever, right? So all the atoms, all the stars, all the galaxies that we see in our telescopes, that's 5% of the mass. And then dark matter is 25%. And dark energy, which is something completely different, is the other 70% of the universe. And those are facts. That's basically 99% likely to be true. What it is, the dark matter, the dark energy, that is much more up in the air. We have lots of candidates, and we're not sure which one is right.
Boy, that doesn't help, does it?
Well, so I went on Science Friday. Science Friday with Ira Flato, NPR show.
Okay.
And he says, like, you cosmologists, like, shouldn't you be embarrassed? You only understand 5% of what's in the universe, right?
That's amazing that
and
you know
like,
that much.
Yeah, we know 5% of what's in the universe. Like 100 years ago, we didn't know anything about the universe. We didn't know the universe was expanding. We didn't know there were other galaxies. Come on, this stuff takes more than a few months to figure out. Right?
5% I think is pretty healthy.
Yeah, I think we're getting there.
What is the current theory as to like where it resides and how it's formed and what its properties are and what impact it has on the galaxies?
I think this is a really, really good question because we might be in flux right now. For a long time, like basically from the 1980s to today, there was a leading candidate for what the dark matter was, something called the WIMP, the weakly interacting massive particle. Okay, so if you indulge me for just a second, we have the particles we know and love. There are 4 forces that push these particles around. There's gravity, there's electromagnetism, and then there's the strong and weak nuclear forces, 2 nuclear forces. And the nuclear forces are distinguished by being short range. Like you don't notice them in your everyday life. You got to be down there at the atomic scale. So it turns out that if you imagine a new particle that obviously interacts through gravity because everything interacts through gravity, but doesn't interact through the strong nuclear force like a proton does, or through electromagnetism that would be charged, but it interacts through the weak nuclear force. Okay, so you imagine a particle interacts through the weak nuclear force, relatively heavy, and you calculate how much of those should be left over from the Big Bang, you get the right amount to be the dark matter. So this is called the WIMP miracle. The idea that if you just hypothesize out of the blue a new particle that is invisible and stable and interacts through the known force of nature that we call the weak nuclear force, that could easily be the dark matter. So that seemed so natural and simple, and there were many more complicated theories that predicted that such particles would exist. I would say that many people 10 years ago or so would have said there's a 90% chance that WIMPs, weakly interacting massive particles, are the dark matter. Here's the problem. If the dark matter is WIMPs, we can build detectors and look for them. And we have done that. We've built these giant detectors deep underground. You're shielded from all the cosmic rays that are just noise and contaminating your experiment. And you wait for a little weakly interacting massive particle to pass through your detector and bump into an atom.
Underground?
Underground, so
How
you're
deep
shielded.
underground?
Usually these are in mines, right? So they're in old gold mines, a mile underground.
How counterintuitive. So you're going a mile underground to search for something that's in space.
I made up the mile. You might want to, if you can Google.
Well, even deep. Even
dark
if it's
matter detectors,
100 feet underground.
It's in a deep mine, right.
That seems so counterintuitive.
Yeah,
like you would think you'd have to throw something into the sky.
We live in a noisy environment.
Right.
The trouble is not detecting them. The trouble is seeing them peek out over the noise.
Oh, okay.
That's what we're trying to do. It's like going into a quiet room to listen to something very, very faint.
What was the initial discovery that led to the conclusion that dark matter is the preeminent mass of the universe? Like, what percentage of the mass is it?
Well, sorry, let me just finish this thought very quickly because the point is that we have built these detectors and we haven't seen the WIMPs.
Oh, okay.
So for the first time, people are beginning to shake their belief that maybe WIMPs are the most likely candidate. There are other candidates, other kind of particles that could be the dark matter. Maybe it's still WIMPs and we just haven't found them yet, That's still possible. But I would say if 5 years from now we haven't found the WIMPs, then people are going to start saying it's something else.
Okay.
So the first evidence, it comes in drips and drabs. My Caltech predecessor, Fritz Zwicky, famous astrophysicist, back in the 1930s, pointed out that galaxies were orbiting each other too fast in what are called clusters of galaxies. You look out there in the sky, you see like these bunches of galaxies that are orbiting each other. If you calculate how heavy the galaxies should be from what you see, you can calculate using Newtonian laws of physics how fast they should be orbiting. They're actually orbiting much faster. And he said the only way for that to happen is if they're much more massive than you thought, if there's much more mass in there. There's some missing mass, okay? But at the time, we didn't know it could just be stars that we didn't see, or gas, or dust, or whatever. It wasn't really till the 1970s that Vera Rubin, a famous astrophysicist, looked at how individual galaxies are rotating, and she found that it's a similar kind of thing. The edges of the galaxies are moving way faster than they should be, given the amount of matter that is inside. And she concluded that there's a lot of dark matter causing a gravitational pull that we didn't see, but is causing the edges of the galaxies to spin a lot faster than they should be.
Wow. So that is the reason why. Is there a possibility that some new discovery could happen or could come forth where you would re-examine this idea that there's some missing mass?
There's always a possibility. So there's certainly this idea that is on the market that because all of our evidence for dark matter is indirect, because it's through its gravitational influence, not by directly touching it or seeing it, maybe we just don't understand gravity, right? Maybe gravity is a little bit different. Now, I would argue, and I think I'm right, not everyone agrees with me, sadly, but that idea has basically been killed off by our observations of the microwave background radiation. We are 14 billion years after the Big Bang. There was, the Big Bang was very, very hot and dense and was glowing to beat the band everywhere, but it was also opaque. The light didn't get very far. And about 400,000 years after the Big Bang, it cooled down enough it became transparent. And then these photons of light just stretched, traveled through the universe unimpeded, and we can see that, the leftover radiation. We can see these faint patterns, these oscillations in the microwave background, which look exactly like they would look if dark matter were causing them. And they don't look what they would look like if gravity were modified. So there's a much longer version of that story, but the basic thing is, if I can just pull authority and say, trust me on this, I was totally on board with the idea that there was something wrong about gravity. That would be a very cool thing if it were true. That would be a big mind-bending discovery. But we've tested that. And the microwave background, there were predictions. It would look this way if you modified gravity, that way if there were dark matter. And the answer is spot on to the dark matter predictions, very different from the modified gravity predictions. So dark matter exists.
So dark matter exists. And what percentage of the universe is currently believed to be dark matter?
25%.
25%.
Yeah.
And I read once that they had discovered an entire galaxy that was made out of dark matter.
Yeah, pretty close. Maybe not entirely, because then you wouldn't see it.
Right.
It's hard to discover it.
That was what I was going to ask.
Right.
How do you see this stuff? Like, how does, if you can't detect it, you know it exists, right?
Right.
You know because of its effects.
That's
but
right.
you can't point to it like you could point to the sun.
Right. So you need some tracers. You need something that tells you that dark matter is influencing the motion of stuff in this vicinity of space. So in a galaxy, it's just like the stars at the edges of the galaxy. And most of the mass in our galaxy is dark matter. Like we see these pictures of galaxies that you see that look very beautiful. The actual size of the galaxy is much bigger than that, but it's all dark matter.
Oh.
The galaxy you see is a tiny little puddle, 1/5 of the total mass, that it sort of settled down to the center of this big puffy cloud of dark matter.
Whoa.
And when people say, well, there's a galaxy that is only dark matter, what they really mean is it's almost only dark matter. It's a puffy cloud of dark matter where most of the stars have been pushed out by something, but some of the stars or the gas you can still see orbiting around, and that tells you there's some concentration of dark matter there.
Do we know what dark matter is? Or are there any
There's
theories?
lots of theories.
Yeah.
WIMPs were the biggest theory, but there's alternatives. There's one alternative. It could be small black holes that were made in the very early universe. That seems unlikely. There's another kind of subatomic particle called the axion, which is nice because people invented it for totally different reasons, and they also worked out that could give you exactly the right abundance to be the dark matter. And there's dozens of different theories out there for what it could be. So we're trying to figure out which one is right.
What a weird thing to have something that's invisible, that's a giant percentage of the entire universe and a large percentage of galaxies, right?
Yeah.
What percentage of galaxies is dark matter?
Most,
Most.
Yeah.
90s?
Yeah.
In the 90s?
Yeah, well, let's say 75%, 80%, something like that. Depends on the galaxy. But on the other hand, what right did we think? Did we have to think that most of the universe should be readily visible to us?
Now, does dark matter exist on Earth, or is it only in deep space?
It depends on what the right theory of dark matter is. But in most theories, there are dark matter particles passing through your body right now.
So with this WIMPs detection theory, where they've developed these detectors deep into the ground, would be able to detect something that's actually prevalent here on Earth.
Right. Yes. And it's not that they're stuck to here on Earth. The Earth is just moving through space, and there's a wind of dark matter particles that we're passing through and occasionally bumping into.
Right, and we're moving in some sort of a spiral through the universe.
Because the sun is moving and we're orbiting around the sun. Right, yeah.
Oof. Now, the Big Bang one is another weird one. Because I was watching this thing on television that was proposing alternative theories to the Big Bang, and one of them was that the universe is next to another universe, and that somehow or another it collided with this universe, and that this is probably a process that repeats itself.
I know. We get paid to come up with these ideas, and that's what we're doing, there in Starbucks with a pencil and paper. Yes.
What, do you buy into that? Like, which one do you buy into?
I don't think that works.
No?
I don't personally think that that's very likely. It's on the table. It's a reasonable.
Is it still on the table? Was it a recent?
Yeah.
One?
When was it first suggested? Maybe around 2000 or so.
And did a bunch of people jump on board, or say if something like that comes up, one of your colleagues has this idea, so then you go to the cafe with your legal pad and go, all right, how do we do this?
Exactly, that's right. And so what you would do in that case, so someone proposed an idea, and you say, well, okay, how would we test it? How would we know? Well, maybe. Like we said before, maybe it predicts some pattern in the leftover microwave background radiation from the Big Bang. If you're a different theory for what happened at the Big Bang, then maybe your imprint post-Big Bang is a little bit different. And that's exactly the kind of thing we're looking for now.
So the imprint, the microwave imprint of the Big Bang, this 14 billion year old event.
Yeah.
What is Terrence McKenna had a fucking hilarious way of describing it. I'll do a terrible job of butchering it. But that people like this. It's funny how he was talking about how many scientists are atheists, that they don't want to believe in God. They don't want to. And he was an atheist as well. He was an atheist rather as well. But he said, but they do want you to believe that everything came out of nothing for no reason that anybody knows of 14 billion years ago. That there was this infinitely small area that was smaller than the head of a pin. And that's everything you see in the sky, and it exploded 14 billion years ago, and no one knows why.
That's right. Yes. Good.
But isn't that a weird? I mean, that is so crazy. And it's one of those things that theists, people that are really into gods and religion, they point to, like, well, this is the scientist's God. This is this event. This is a miracle. I mean, this is the way bigger miracle than walking on water or turning wine into water into wine. I mean, that's baby stuff.
Except that this scenario would be 100% compatible with the laws of physics.
Right.
In a way that turning water into wine is kind of not.
Yeah.
I think that so here's the thing, and I think this is actually not always communicated very well. The Big Bang is the phrase the Big Bang is used in two different senses. One is what we call the Big Bang model, which is the whole history of the universe for the last 14 billion years from an original hot, dense state, expanding, cooling, galaxies form, here we are. That's true. That's settled art. We know that that's right, okay, the Big Bang model. But then there's also the Big Bang event, the beginning of that story. Time equals zero, the initial singularity. It's a prediction. If you remember, we talked about in black holes, you have general relativity, Einstein's theory of gravity. it makes predictions. And one of those predictions is if you trace the universe backward in time, you hit a singularity. You hit a moment when everything was infinitely dense, infinitely fast expanding, et cetera, et cetera. That's the Big Bang moment, and it is certainly not true. It's the opposite of true. We have no right to believe that actually happened because it's a prediction of general relativity, but general relativity is not right in that regime because you're ignoring quantum mechanics once again. So if you don't think that you understand the fundamental quantum mechanical rules of the universe, you have no right to say what happened at the Big Bang. And what physicists should say, if they're being honest, is that could be that there was a first moment in the history of the universe, a first moment of time, a day without a yesterday. And once we understand quantum mechanics and gravity and how they play well together, that will all be very clear. Or there could have been something before. There could be what we call the Big Bang may have been just a phase the universe goes through occasionally. And this bouncing universe idea that you were talking about with the two different universes hitting each other, that would be an example of a scenario in which the universe actually was eternal, that it lasted forever. And right now we have no way of knowing. We're very open-minded. It's 14 billion years ago. Maybe it was the beginning. Maybe it wasn't. We just don't know.
What do you take of the idea that the Big Bang is a process, a continual expansion and contraction process, and that it starts with the Big Bang, the universe expands, and then somehow or another pulls back into itself until it becomes this infinitely dense small point again, and then the whole process starts from scratch?
Right. Yeah, that's one of the scenarios on the table. In fact, this idea that you referred to, which was what was originally called the ekpyrotic universe. Don't ask why. It was some ancient Greek word.
It's a cool name.
Yeah, it's a cool name. So that was the idea. There's this extra dimension and two universes smacking into each other. They later realized, the same people, very well-known, respectable physicists, realized they could just play the game over and over again. So you could have this smacking together, call that the Big Bang. It expands and cools, but then it recontracts, and there's another bounce, and this goes on an infinite number of times. I am personally not that fond of this idea. Number one, there's no evidence whatsoever or reason to believe that our universe will ever contract. It's not only expanding, but it's expanding faster and faster. It's doing the opposite of what you would expect if it were going to contract. So I don't think that's very likely. And number two, the single most impressive empirical fact about the universe is the difference between the past and the future, what we call the arrow of time, right? You remember the past, but not the future. You make choices now that affect the future, but not the past. So this difference between the past and future is nowhere built into the laws of physics as we know them. All the laws of physics that we know treat the past and future the same. The reason why there's a difference is because of the Big Bang, because the Big Bang was a very, very special, organized state that the universe could be in. And ever since then, we have been expanding and cooling and sort of winding down. And that's the fact you have to explain if you want to explain the origin of the universe, in my view. And the idea that there's an infinite number of cycles doesn't explain that fact at all. There you go.
Lawrence Krauss is trying to explain to me the size of the universe and the age of the universe. And he was saying that 14 billion years, like when we look back into the known universe, like what we can see is like 14 billion years.
Yeah.
But he was saying that essentially doesn't mean that that's as far back as it exists. It just means that space is moving faster than light. When you get back to that distance, there might be something even further back than that, but we're not going to ever be able to see it.
I hope he didn't say exactly that.
I'm sure he didn't.
Right. So
I fucked that up, I'm sure.
But again, sometimes even my favorite people in cosmology use this language of space expanding faster than light. Entirely bullshit.
Oh, okay.
Because space doesn't have a speed. The expansion of space is the answer to the question, space is this big. By what amount has it expanded in 1 year or 1 second later, right?
I have heard that expression before, that space is moving faster than light. So why do they say that?
They shouldn't say that. They should stop saying that. I know, because they're lazy and bad. That's why they're saying that. Yes.
So these are like high-level guys.
Yeah, I know.
Okay. So what is the...
Never going to be invited back to a cosmology conference after this podcast.
Well, you always have the infinite monkey cage. They'll
I have
you
that.
Back.
That'll be my new career. Right.
So what is happening then?
Well, space is expanding and light is moving through it. Okay? Right. And what is certainly true is that the speed of light is a finite number. Right.
Right.
It's 1 light year per year is the way to remember it, right? So if the universe had a beginning, a finite number of years ago, then there's only so far out that light can get between now and then. That's all there is. So there are things far away that are so far away we can never possibly see them at this current age of the universe because it would take longer than 14 billion years for light to get from there to here.
Oh,
and that's just because the universe has a beginning. It has nothing to do with the fact that space is expanding at this speed or that speed.
Okay. If there is a point where the Big Bang begins, right? There is a single origin point, and it explodes outward, and we are seeing it from some position. So we are seeing this explosion 14 billion years ago. Does it move in the opposite direction as well? Is there 28 billion years in from point to point?
Right. So it's not like that.
No.
The Big Bang is not a point.
Okay.
The Big Bang, and this is hard to wrap your mind around. The Big Bang is not a location in space. It's a moment in time.
Whoa.
It is the time in the history of the universe when everything was on top of everything else. It's easier to talk about 1 microsecond after the Big Bang than the Big Bang. 1 microsecond after the Big Bang, the universe could very well have been infinitely large. We don't know. It's not like the universe started small.
A microsecond.
Or any other time. Yeah.
Infinitely small. Well, let's forget
don't
about
call
it.
It infinitely small.
Okay. Insanely small?
Things were closer together. There's no such thing as the size. If the universe is infinitely big, it's always infinitely big.
Okay.
But you can still have a Big Bang.
Oh, okay. So if all matter is condensed into a very small spot, it doesn't mean that all things around it are not infinitely large.
Well, you don't want to say around it because we're talking about the entire universe. So visualize an infinitely big universe full of stuff. Okay.
Stuff.
Stars, galaxies.
Okay.
Stuff.
Like right now.
Yeah, like right now.
Okay. Okay.
And wind the clock backwards. So
suck it all in.
Yeah. So the thing is that as far out as you look, even if you look at, with your God's eye view faster than the speed of light, there's still stuff out there. It's uniformly spread, let's say, okay? So, but it's closer together. It's the relative size, the relative distance between galaxies and stars is smaller in the past than it is today. But the whole size of the universe is still infinity. And that's still true all the way back 14 billion years right up to the Big Bang. The universe could have been infinitely big, but the density, the amount of stuff in a cubic centimeter, goes to infinity.
Whoa.
Yeah.
How big is the estimation that it was at the moment of the Big Bang? Before it expanded?
Right.
It's thought to be fairly small, but infinitely dense, right?
Well, I don't even think you can say it was thought to be fairly small.
No.
The observable universe. So I think this is maybe what gets lost. Because the universe is finite in age, we only see a part of it. Okay? We see a part of it a few tens of billions of light years across. Call that the observable universe. That's finite in size. Okay? So that definitely was smaller, and there was an actual number you can attach to the question, how big was it at the Big Bang? And we don't know the answer. We can sort of, it depends on theoretical predictions. It was the biggest possible size it could have been was about 1 centimeter across.
The biggest possible?
Yeah.
As big as it could be. So you're talking about essentially like a pinky nail.
That's right.
That's as big as the whole universe could have been.
That's right. In fact, in this, so everything you see, everything around you right now that you can reach out and touch, every galaxy out there with billions of stars in them, they were all condensed into this 1 centimeter cubic region of space.
What is the largest?
And it could be much smaller. That's the largest it could have been.
That's the largest?
Yeah.
That's as big as it could have been.
It could have been much smaller.
What is the smallest it could have been?
What we call the Planck size, 10 to the minus 35 or 10 to the minus 40 centimeters, something like that. So incredibly tiny.
Invisible.
Oh, yeah, very, very invisible. Yeah.
Whoa.
Yeah.
Why do we think it happened?
Well, what is the reason?
Yes.
The evidence we have?
Yeah. Like what is the current theory as to what the Big Bang? Like why did the Big Bang take place?
Well, that's a good question. So there's no preferred conventional answer. We just don't know. That's not a we don't know because we're not sure. That's a we have no idea is the answer. Obviously, if there was a bounce or if there was some universe before ours out of which ours came, there would be a sensible answer to that. We just don't yet know what it is. It's a more challenging question if you think that the Big Bang was truly the beginning of the universe, which is perfectly plausible. That's perfectly compatible with the laws of physics. And then you're in one of these situations you have to reorient the kinds of questions you allow yourself to ask. Because if the Big Bang was the beginning, there's this intuitive feeling that there was a time before the Big Bang when there wasn't anything, and there was nothingness, and nothingness sat around for a long time, and then it decided to bang, okay?
Right, it could have sat around for an infinite number of years, right?
Yes, but don't think of it that way is what I'm trying to say.
Okay.
Don't think about nothingness transforming into the Big Bang.
Okay.
Think about our universe. Think of it from the other side. Think of it from the side that we already exist, but visualize into the past. And imagine that as you visualize into the past, you hit a beginning. You hit a first moment of time, a time when time itself came into existence. But there's no time out of which it came. That's the beginning of time.
Okay.
It's like walking north. You hit the North Pole. Once you're at the North Pole, you can't keep going north.
Right.
There's nothing weird. It's just that every direction you go in would now be south. At the Big Bang, time is only toward the future, not toward the past.
That's the sound of my mind blowing.
Is that the arrow of time?
The arrow of time is the particular fact that not only does time flow, but the universe changes. There are differences between the past and future.
God
as
damn,
time goes
man.
on.
This is tough. This is tough to... How do you guys sleep?
No, not very well. Actually, when I was a kid, like it was 10 years old or so when I first got interested in this stuff. And so, yeah, when I was 11 or 12, the thing that would stop me from sleeping was I'd be, dreaming about, the Big Bang and the universe. And then I would come to the beginning and I would go like, but what if the universe had just chosen not to exist? And then no sleep for me that night after that.
Like it had a choice.
Right. I know better now. I moved on to other more worldly concerns keeping me awake at night.
So is there anybody working on any sort of theory to try to understand what forces might have caused it to burst forth?
Yes. So, there's two answers to that. One is yes, I'm one of them. There's plenty of people thinking about this kind of question. But really, I hate to say it, but you shouldn't ask that question. Because, again, we're embedded in this world. So the question you asked was, what are the forces that caused it to burst forth?
Right.
So that presumes that there was a cause.
Right.
And that, causes and effects work themselves out over time. So that there was a time when there wasn't a Big Bang, and then there was something that caused the Big Bang to occur.
Right.
So what I want to suggest is that that's just not the metaphysical framework in which to think about the origin of the universe. Don't ask what caused it. Ask what were the laws of physics that can be compatible with both the universe we see today and with the universe having a beginning 14 billion years ago. We don't know the answer to that, but that's the question we should ask.
It's such a complex discussion. It's so complex that it's almost like infinite in its possibilities. That you go over all these variables, these possibilities, and what we know and what we're learning, and it's just.
Well, it's complex, but more importantly, it's a realm that is just so far outside our experience and our toolkit for dealing with the world that we have no guidance, right? We're kind of at sea. Like, what are the kinds of things we should be asking about? What are the answers that would satisfy us, right? I would argue that there are brute facts. There are things we just need to accept. If we come up with a picture of the universe, a set of laws of physics, and a story for the history of the universe that says, well, the universe started this way and then that happened, etc., and someone says, well, why did it happen that way? And I would say there is no answer to that question. This is just what it is. I might change my mind if you convince me, but there's no right to demand that there is a reason why things are one way rather than another.
Do you have difficulty thinking of a potential reason that one day we will wrap our heads around? Do you think that it's within the realm of our possibilities or our understanding?
It's always possible that there is a deeper explanation, right? Mm-hmm. But then you want to say, well, okay, why is that deeper explanation true? And I think that this chain of explanations bottoms out. I think that there will be one foundational point which is not sort of self-explanatory, but is just, and that's the way it is.
Whew. Are there any legitimate scientists that are contemplating the possibility of a Big Bang not being the origin of the universe?
Oh, yeah, absolutely. The Big Bang could be just one of these moments, one of these things that happens. One possibility is that there's another universe that is sort of big and quiet and empty, but through a quantum mechanical fluctuation, a little part of the universe could pinch off and become a separate baby universe and then grow by itself, and that could be the origin of our universe.
So like a stellar nursery for universes?
Yeah.
Boy.
And it could go on. The great thing, so I haven't blown your mind yet, but now I'm about to do it.
Oh, you already did. Let me put it back together again real quick.
When you look at the universe, if a universe is finite in size, we were talking about it could be infinitely big, it could be finite in size. But if it is finite in size, we think that a finite universe has zero total energy, zero total charge, zero total velocity, etc. So making a universe costs nothing. Alan Guth, who's a famous cosmologist at MIT, says the universe is the ultimate free lunch. Universes are not an expendable resource. You can make if you can make one universe, you can make an infinite number of universes just as easily.
I don't understand that. How is it?
Well, so
do you understand it?
There is, there's math, right? So look, you look at the sun and you say, look, the sun, that seems to be like it would be hard to make. A lot of stuff there. It can't just appear. But the sun also has a gravitational field, right? There's gravity around the sun. And what the math suggests is that there is energy in the gravitational field of the sun, which is negative, and which is exactly equal to the energy of the sun and cancels it out. So that if you had a universe with nothing in it but the sun, that universe would have zero total energy if it were closed in on itself.
Whoa.
Yeah.
It cancels itself out.
Yes.
So
the negative energy in gravity cancels the positive energy in stuff. Therefore, universes can have zero total energy. And this is all obviously very hypothetical, speculative, mathematical stuff. This is nothing we've done in the lab, so take it with a grain of salt. We could change our minds, but that's the current state of the art.
Wow. So the entire universe, you believe, revolves around that principle?
Free lunch, yeah. You could easily... So again, if you can make a universe at all, then you can probably make an infinite number of universes just as easily. It's not like you have 100 pounds of universe stuff and that gives you a finite number to make. Every universe costs you nothing to make.
People have a hard time even thinking of there being more than one universe. And you start thinking about the fact that there's 100 million galaxies in this, or 100 million, at least 100 million solar systems, right? In this galaxy, this is one of hundreds of billions of galaxies in the known universe, and that there might be more than one universe.
Right. And the idea that this was all for our benefit seems a little ridiculous to me. We're very, very tiny compared to the size of the universe.
Yeah, well, that does get to be a bit of an issue. At a certain point in time, just the mass of it all is it defies not just our understanding, or like for the average person like myself, it defies your ability to put what you're describing into words.
Right.
That's part of what the problem is.
Outside our training, as we keep pumping into. But here, I can restore your thought that we matter for the universe.
Oh, bring it back, because we're wrapping this up.
In some sense, we are in the middle of the smallest scales in the important part of the universe versus the largest scales. If you look at the universe on very, very small scales, or very, very early times near the Big Bang, the universe looks very simple. Not a lot of complications. Like we said, you can't build a civilization on an electron. There's just no possible intricacies there. It's a very simple thing. The universe is also very, very simple on large scales, and it will get only simpler in the future. The universe is sort of dissolving into emptiness as the universe keeps expanding. It's only in between, on scales like the size of a human being or the Earth and ecosphere, that things are complex, right? So even though we're much smaller than the size of the universe, we're very big compared to atoms. The number of neurons in a human brain is roughly the same as the number of stars in a galaxy. So we are kind of a peak of structuredness of the universe, of complexity. I mean, until we build even bigger artificial intelligences and so forth. But there's something that we are maximizing, something that is sort of concentrated on us, which is not size or scale or time. It is complication and complexity.
Wow. Now, in the same sense that the energy and the gravity of the stars sort of manage to cancel each other out,
Yeah.
is that the case with people as well?
Well, if this is all, again, math.
Right.
You know,
the whole universe is a free lunch.
Yeah, the claim would be that if you consider a universe with nothing in it but you pick your favorite thing, a person, a star, a galaxy, whatever, then the total energy in that thing minus the total energy in its gravitational field, because that's negative, would be exactly 0.
Wow. That is super hard to wrap your head around.
Yeah.
And then there's the big question, right?
We wouldn't get paid the big bucks if it were easy.
The big question is why?
Yeah.
Like, why do you think this is all happening? Or do you ever use that word why? Because why is a weird word, right?
Yeah, why is a weird word?
It is happening.
It is happening.
So what's causing it to happen? What are the forces that cause it to happen?
Yeah.
But ever why? Do you ever look at it all and go, is there a purpose to all this?
So, sure. And I think the answer is no. I think that
no purpose.
I think that, yeah, there's no reason why. And again, just looking up into the sky, unless the purpose was to make a pretty sky, boy, anything that we're seeing here on Earth could have been done with much less effort than making 100 billion galaxies, right? There's no evidence in anything that we've learned about science or the universe that gives us a reason to believe that there's a purpose behind it all. If anything, as time goes on, the entropy of the universe is increasing and the universe is becoming more random and disorderly. I think that we're, riding a wave of a universe that is growing and expanding and cooling and becoming more and more disorderly, and that's a finite amount of time. So 14 billion years from the Big Bang to today sounds like a lot. That's 1.4 times 10 to the 10 years. But the future of the universe is enormously longer than that, according to our best current theories. It's potentially infinitely long. Anyway, the last star is not going to burn out until a quadrillion years from now. We are very close to the beginning of the history of the universe. But it's not forever. It doesn't last an infinite amount of time. So the universe is ephemeral. We human beings and living creatures are temporary structures within it. And the idea that it's all for some big cosmic purpose seems to hold very little water.
Do you ever contemplate what function human beings have in the universe? The way we interface with reality, the way we interface with the nature around us?
Yeah, I think that we don't have a function. I don't think that's the right way to think about what human beings are. We should be glad to be alive, enjoy it while we're here, be nice to each other, and try to learn more about the universe. But it's not, if we choose not to do that, that's not going against any preordained function that we have.
You're remarkably calm when you discuss these things. Like, do you have any existential angst? Do you have any
No. I think it's the other way around. And honestly, this is very, very small amounts of data. But from what I can tell, when personal tragedies strike, people who are atheistic cosmologists and scientists deal with it way better than people who think that we're embedded in a matrix with a bigger purpose or a spiritual reality.
Really?
Yeah, because you get that this happens.
And you
it's
have
inevitable.
a perspective, an infinite perspective.
Yeah, it's not good.
Were.
Like when someone dies, it's sad. You can be sad, but you can't say, well, it shouldn't have happened.
Right.
These are the kind of things that happen.
Damn, dude. It's going to take a while to process this one, man. This is a long one.
Go out and look at the Milky Way.
I'm going to have to listen to this about 30 times and take notes. But thank you very much, Sean. That was awesome.
My pleasure.
Really appreciate it.
Yeah,
thank you so much. If people want to get a hold of you or read some of your stuff, what is the best way?
I have a website called preposterousuniverse.com.
What a great name.
And, my last book, The Big Picture, talked about all these questions about purpose, why we're here, what we should do about it.
Is there an audiobook available as well?
There is. I recorded it not far from here.
Excellent. Beautiful. Thank you so much, man. That was
Sure,
awesome.
My pleasure.
Thanks, everybody.